Right, hello everyone. Hey, this isn't right. My picture's wrong. This is going horribly wrong. It's like this is not widescreen like it should be. Hey, that's better. Glitchy software. And this camera's moved. Anyway. So we got Willem, Firehouse. If you're here, say hello in the chat so I can see you here. Yes, it's been an interesting couple of weeks. XDevs, how's it going? Ilya. What are we celebrating? I don't know about celebrating. I've got some gear to work on. Nothing, well, I don't know if it could be exciting or not. It could be. Could be smoke and flames, who knows? Can't tell. Like, let's have a look. Got a little project on the side here. It goes very, that's almost lined up. So I'm playing with over there. Ian, you made it. I thought you were going to a party and having some fun or something, having a life outside of YouTube. Anyway. Put you down your bag of chips. Are you back from the party already? That was early. Okay, cool. So, I was playing with something yesterday. Like the last live stream we did, we were looking at trying to do the battery system for that Keithley 150B. And I didn't have the right parts, or I don't know, it seemed doomed that last live stream, didn't it? Had the bloody power cut the previous day. So yesterday I started mocking it up, and it's a yeah, it is a picoammeter actually. Yes, microammeter, I think it is. This beastie here. Microvolt ammeter. There you go. So, this thing normally has a battery pack inside it, which has been removed, which we probably talked about before. For those that weren't here last time, they wouldn't know. Hey, Dave. And the unit came to me with no battery in it, and it's been removed completely and stuff like that, which is fine. But I need to put it in. But I don't want to put in just a plain NiCad, as we discussed before. I'm going to put in nickel metal hydride, and I wasn't happy with the charging voltages, so I've had to build a little system to handle that. Now I've mocked it up on the bench. I'm actually still doing testing right now, which I can show you, and I actually have it charging a battery right now. Just doing testing since yesterday to see how the charge rate actually stabilises and that sort of stuff. I've mocked it up with my DC electronic load, and that seemed to behave correctly. I've actually built one, so I've got the mock up on a breadboard, and I've actually got a little piece on a bit of perf board I built up, which is what I want to intend to put it in. So fingers crossed it all works alright. And let me just bring up the monitoring system. It should work. Let's boot this up. Got the test controller software. I don't think I've used it in OBS since I did the computer upgrade. I know it works in itself. I was testing that yesterday, just making sure it worked. Hey, it showed up in OBS. Brilliant. It's just the wrong size. That's fine. We can sort that out. Let's adjust the size of this panel. Most issues don't actually need to see right now anyway, so I'm not really too worried about it, but Yeah, I think they changed quite a bit. Go on, there's the panel we want. There we go. It's a massive panel. So this has got various bits of gear on it, which I'm probably not even using right now, but that's fine. So, directly beneath my face here, you can see 6.85 volts, which is being monitored by my electronic load. I don't actually know I'm going to use that Keithley for yet, Ilya. It's probably just a case of me just having a piece of gear to use when I need to use it. There's no specific purpose in mind. New batches for the UPS, well, yeah, that's something I probably need to look at. Obviously, these ones which I salvaged last time weren't doing as well as the previous ones I salvaged. The last ones which I salvaged lasted hours before they were flat, and this one, as you saw last time, didn't last. Hey Adam. So, let's go back here. There you go, it's kind of good enough, I suppose. Tweaking this bloody sizing. Right. Yeah, so what I've basically doing is I've got the DC electronic load, and just barely sit. It's a bit small on it, really. I don't like that layout. The font looks a bit small for my liking. Let's sure I'll make this better. There you go. That's slightly better, isn't it? Make it taller. Alright. Hey Rob. Oh, no, moving on thing now. Let's do that, there we go. Okay, it's not fiddly. Yeah, so where was I started off with this? So I've now mocked up a little, just basically a charging circuit, right? I choose a LM337 negative voltage regulator, tweak the values of resistors to try and get the profile I want, so that it will be about the right charge rate and reduce the charge current when the battery should be full. I did actually tinker around using two LM337s, one as a voltage regulator and one as a current limiter. And that worked. I just had two in series. And that was working fine. So I actually limited the current to like 100 milliamps, stuff like that. And that was working. But then I decided that I didn't really need the current limiter. It was actually doing okay without it. So to simplify the circuitry, I've just left that bit off. It doesn't really need it. Just having a precise voltage control was good enough. That's working okay. So it will do about 150 milliamps or so charge at 5 volts. Maybe 108, maybe 160 milliamps something like that, at 5 volts charging the battery, because it's going to be using a 6 volt cell. And then up to 7 volts it drops right down to about 4 or 5 milliamps. About 7.1 volts on that, which is like the top end of what the cell should be charged to. So I've had this thing charging an actual battery to prove the concept since yesterday. I put it on about probably 10 o'clock yesterday. So it's been going for about 22 hours. And the cell started out as pretty well charged anyway. I think. Maybe not fully charged. It's about 6.3 volts. 6 volt cell. It's now to 6.8 volts, or 6.85 as you can see on display here. And the charge current is about 9 to 10 milliamps right now, as you can see from the power supply, which is outputting 16 volts. And that current is supplying the whole circuit, not just the battery. So obviously some of that power's going to the regulator itself. You know, it won't be much, but a little bit of that will be going to that, maybe a milliamp. So yeah, that seems to be working fine. The clicking you can hear is a hard drive. It's my NAS. which decides to do backups at inconvenient times. Let me check it. Which one's going? It's not that one. Yeah, it's doing a sync in itself. It's doing an internal sync. So there's nothing I can do about that. Yeah. Anyway, I feel like I'm sitting too low now. I've got a test controller below me. Should I put the test controller up the top instead? So I'll do that instead. Is that better? Might be better. Yeah, anyway. Yeah, so the plan is to actually put that circuit in. I'm going to demonstrate a circuit to you, show you what it's actually doing on the one which is on the breadboard, which is mocked up already, and then we'll install the one I built, and we'll just see how it goes. And always the other thing I've got to do is I've got to replace some resistors in there for the 60 Hz filter. It's got some precision resistors in there which I need to chop out. I purchased some resistors for it, and that's got to use the cadmium solder. I need to use that in that section because it's in the input section. Agreed. So yeah, yeah, I've got to use the cadmium solder which is inside the Keithley, which is nice. That section uses cadmium solder. So yeah, there's actually cadmium solder, little section of cadmium solder left inside the unit to use inside the input section. So if you do any work on that, you need to use that solder. Transparency setting, yeah, well then you wouldn't be able to see it too well, would you? I mean, I can change the colour, I can make it black. I can make it disappear by making it go black, but then the text might be visible. I don't know. I can change colours, but I haven't bothered. Yeah, that's what they used. That's what Keithley used at the time, and so cadmium solder it is. That's what I have to use. Keep it original. So there's two precision resistors on the input circuit. The input passes through them, and those are part of a 60 Hz filter, which I need to convert to be a 50 Hz filter. So I need to swap those resistors out to a different value. And there's also another standard resistor, which is like a 10% carbon composite resistor on the same board, which I can swap out with another standard resistor. I'll need to swap that as well for a 1K. So I've got to change three resistors on the input board. That should then enable the 50 Hz filter instead of a 60 Hz filter. So that's something else I need to do as well. Anyway, and I was going to see how my voice goes because I'm still getting over having COVID. That's great. So I'm not fully over it yet. Well, I felt about the same now for about the past 4 days. I'm kind of normal but not, and my voice is still struggling a bit. Ordered some metal films. Ordered them. It's going to take 2 years to get them. Jesus, that's bad. The panels which currently aren't showing up are actually labelled underneath them, so you can see the controls underneath the readouts. So your readouts top and controls underneath. And so the very left one is my LCR meter. The second one over is my 6.5 digit Siglent multimeter, and the very right hand one is my signal generator, my function generator, arbitrary waveform generator, what you want to call it. In normal times it's a year. Oh, okay. Even a year is still quite a long time to wait for bloody parts, isn't it? I suppose they're all custom ordered, eh? They're all custom made. I have to say I've never actually ordered custom made parts like that. Apart from crystals, the only things I've actually ordered ever has been crystals. Custom made crystals. Yeah, so this is a program called Test Controller, and you can use serial interfaces, USB. I'm using Ethernet for most of these things. A couple of things are using USB. black background and green for the panel. Yeah, I'm tempted by that actually. I think I did play with that once. That colouring. And we're going to play with this now, just to keep you all happy. Oh, I just lost it. Oh, I've ruined it now. Lost the panel. And it's all resized. Oh no, it's all messed up now. I'm there. Right. Get the correct panel. This one here. Which is the wrong size. I think better change this now. I think I have to do it per panel. I don't remember. I have to do it per panel. Yeah, so now the text disappeared. Let's pick that one, shall we? I have to do it for each panel. I have to do it for each one. Yes, I do need a 3458A. Definitely do. That would definitely be nicer. There you go. It's now got a green panel. You think that looks better, the green or the grey? Opinions? Yes, I would love to get a 3458A. Way outside my budget though. Even broken ones 3K, yeah, just ridiculous. Cyan letters, you reckon? It was going to grey for you, yeah. No, I think you have to sell it to me, Ian. You have to sell me your one. I don't know. Well, I mean, I've got the Advantest, that 6581T, which is better than nothing. Needs some work, yeah. I still got to do that. Is it linearity thing? Yeah, I've got to look at that. I haven't really looked into it enough detail yet to really worry about it. I've got to rejig this panel so it fits on screen properly. Yeah, anyway. You see in a few months if that helped. Oh yeah. Have you still got your one? Your 6581. Yeah. Yeah, I think the green and black does look better, eh, on that display. I have to keep trying to choose the correct green now. Here we go. It does remember the recent one. That's nice. Yeah, I think it does look better, doesn't it? Let's do that. Just a shame I have to do one at a time. Then we'll play with some gear. We'll see what we can do with this Keithley. Get that sorted out. And I'll show you that battery charger circuitry first before we do that. I'll jump on that, demonstrate it on the electronic load. Show you that functioning. Yeah, look at that. Oh, that did go weird. That's strange that time.
Hi, darling.
Well, my wife is leaving. I just need to go and sort this out. Give me a second. Right. Wife is going out. Which ones was I doing? Background or foreground? Oh, foreground. It says so on the title. Right. Don't interrupt me halfway. I even who I am. Always forget. Okay. Come on, background colour. Right, that's the readouts in black at least. Is that good enough? So the other one costs £800, and then you had to spend $1,000 on a new board. Well, £1,000 on a new board. Try sign like a VFD display. I've got to sort out a VFD for my R6581. No, testing a zombie unit, right? Okay. But it's drifting because it painted the case black. It's absorbing more heat now. Now new unit is 14k. Wow, for a base unit. You reckon you want VFD now? Let's see if I can get a VFD type. I have to make sure I save this, otherwise I'm going to lose these settings. VFD, so you want like a cyan. Probably a lighter cyan. That one there. Like that. Numbers, all the numbers. Hey Christian. Yeah. Okay, we'll go for that one then. Then I'll save this before I forget. Otherwise next time it will be all back to grey again. I don't know. Right. It's quite nice, this software allows you to do these little tweaks just to make it display how you want. It's quite nice it does that. I haven't used the software that much, but it is very useful. You do want to go and play with it. It does quite a lot. 7 segment display. I think you can actually change fonts. Yeah. Now you got me thinking now. We're going to spend my time playing with my display. No, can you change fonts? It's got own font size. Nah, I don't know. I don't think I can. Maybe it is possible. I think that's enough tinkering with that for now. So like I said, I'm getting over having COVID, so I've had the past couple of weeks have been quite interesting, and I'm not 100% right yet. I felt about the same about the last 4 days or so. So I'm kind of back to normal, but just don't feel right. And this morning I woke up with a bad cough. So that was great. I've had a cough for a couple of days. A few days I had no cough, and today, this morning, woke up coughing a lot. So that's great. Anyway. So there are dot matrix fonts, yes. Yeah, I have to look at test control, see if there's a better way of doing it. Actually, let me save this panel. Generate script, generate grid panel as menu. Let's save it before I forget. Right, that's the panel saved, so next time I'll be able to load the right one. You've played a Python Pygame for GUI. I haven't really done a lot with Python yet. I mean, I've done a little bit, but almost nothing. I did put a little bit of time into trying to learn it a little bit and tinker around with some stuff. And mainly what I was trying to do with the Advantest, I was trying to do multiple readings. I was trying to read the Advantest multimeter and the Datron calibrator, things like that. I was trying to synchronize, and I think one of the other multimeters as well. Maybe the Soldatron it might have been. Can't remember. Yeah, so there's something with that it's playing with anyway. Right, so that's enough tinkering with things. Let's actually go and do something, and hopefully it still displays when I change views. And I need to turn some more lights on. I also need to record video on this. And turn my other power supply on. Let's see. Let's do... And the overlay moved. Of course it did. I'll change the HDMI view anyway. We'll overlay that. Shove this up here. Been in PHP past couple of weeks. We're working down our system. Oh yeah. Log everything. When you do anything like that, always log everything. I'm not sure about the panel being up the top. I think down the bottom might be better on this view. Let's do that on this view, eh? Takes up this space. Yeah, log everything when it comes to downloads and anything which is accessing your file system and user interaction. Always log everything. The amount of times I catch hackers trying to break into things by catching it in the logs and seeing exactly what they're doing to try and break in, I can add those contingencies to my system to block them. So yeah. Yeah, you have to log everything. Every little detail. Every login is logged. Every login attempt, failed login is logged. Every weird page action is logged. I'll talk about this now, and I'm going to sit it like this. So, on my websites, which have any kind of front-end facing user interaction, as I said, I log everything. Right. So I have code injected in there which checks every single submission to that page, checks for certain phrases or keywords which hackers would use, or symbols or characters which they would use, and that would actually block that page from loading and log it. Anything which looks suspicious, it would also log. So anything which isn't quite normal, which it detects as being not quite normal, it logs it. So I've caught all kinds of little weird hacker tricks that way. People trying to break into the site by using special characters and doing conversions between types, that kind of thing. I'm trying to break into databases, commenting out text which is injected into the page, that sort of stuff. Trying to do injection. It catches all that sort of thing. So anything which is submitted to the page in a form, or even if a page has a form, make sure everything that it could potentially use or gets put into the database is either sanitized. Definitely sanitize everything, and then log stuff as well, and check it against a bad list of words and phrases, so that then you can filter it all out and catch hackers and stop them. Yeah, it's very important. None of my sites have been hacked yet. Can't say it's impossible, but I put a lot of work into making sure that if anyone is trying, it will kick them out. Automatically does it. It just gone. Anyway. You also have scripts that run as well. So I actually have a script which will automatically clear out old logs. So anything over a certain age, it will just strip them out. So anything I don't need to see anymore, a year old or so, it automatically dumps those out of the database. So, but sanitize everything as well. Everything that comes in, make sure it's sanitized, formatted. Ideally, you do pre-formed statements. So convert the query into a statement you've written yourself. If you can. You can't always do that. Spam bots, yeah. Anyway, if you've got a downloader, then or an uploader, yeah, well, that's right. Extevs. If you can minimise user interaction, the better. You know, even if you've got a system which only you would access, someone will find it one day. So even if it's only like an admin type system, you know, back end for you to monitor your own website and do your own things, make sure all that is protected as well. Because they're actually like dictionary searches they'll do. So there'll be a program they use, and it actually just go to a website and use dictionary terms to try and find hidden pages. Even if there's no links to them, it will just try and find hidden ones. So it's that sort of stuff they do as well. So if you've got any pages which has got a normal name, there's a there's a chance I can find it. Yeah, I got restricted to IP addresses. Okay, right, that's a safe way of doing it. Like one of the things I put a lot of time into was filtering out for proxies and detecting proxy servers, and I put a lot of effort into that and trying to figure out how to detect proxies and to try to dig down to the real IP address. You can't always do that, but sometimes you'll detect something you can detect is a proxy. You can do like you can actually ping back and check for an open port and stuff like that. Common ports are used by proxies. If you find an open port, then it's likely to be a proxy. Next, a little flag as well, which can be useful. Smith forums, oh, okay. Anyway, we're doing something completely different. It's not supposed to be talking about this. Let's get back over here. Just kick it off my chair so I can sit down. Right. This bloody cough, I was fine until this morning. You know, I haven't had a cough for days. And suddenly today it's just been coughing like crazy. It's irritating. Anyway. So I need to record video for this because this is obviously a recorded video I'm going to be doing this for as well. So I need to think about what I'm going to say for a start. Right, here on this breadboard I've got a little regulator mocked up. So this is actually functioning and this is currently charging this battery. It's been on charge for almost a day now. And I'm just monitoring the actual current usage real world. I've already simulated this with my DC electronic load, and I'll show you that in a second up there, just to show you what it's doing. And I'm sure I've got the right values and stuff I need on this to actually get this 6-volt cell to charge nicely and not overcharge. You can trickle charge these nickel metal hydrides. You can put a just constant current on there, but it has to be really small. This one put a recommended load, is it 0.03 C or something? Yeah, 0.03 C is the recommended minimum for these cells. You can't put a high triple current into them. And I'm actually going below that. I'm actually doing less than that. So, yeah, it's something you have to be cautious. I mean, it's not like it's likely to be a problem because this is, I'm just allowing for the fact it could be left plugged in for a week before I remember I need to unplug it, that kind of thing. Because this is the sort of thing I'd use very often, so it doesn't really matter that much about leaving it charging. But I've tried to get the profile right, so it's got a fairly high current charge rate when its battery's very low, and as the charge is basically full, it will drop that charge rate right down, purely by the tuning of this regulator here. So this is an LM337 negative regulator, and I've also got in a series resistor and a diode to stop backflow for the battery into the regulator circuit when it's sitting there idle, not being used. that's the plan. Now I've already built a circuit just here, bit of a spoiler, and this is what we've got. I might actually get this thing built up properly and actually get a design made for a proper board and get this made, because this sort of thing I might use more in the future. So I think I actually will just get one of these boards made up properly and actually do my own board. But anyway, here's a 337, couple of smoothing caps. That's the input side, that's the output side. In this case I put quite a large input cap because the Keithley doesn't actually have any smoothing caps on its charging circuitry. It's just a diode bridge, or it's even a half bridge, and that's it. So that's all it has. So I've added a slightly larger cap here. It's only still 1 microfarad, but it should be sufficient. There's quite a big overhead on it. And I've got 10 microfarad on the output side, and obviously tuning resistors. That big resistor there is the output side, so it passes through. That's just a 10 ohm, and then there's a diode there as well. I've got a couple of wires hanging off right now just to do testing on it and confirmation. But yeah, that's what we'll be putting in. I need to get my tablet going so I can see what the chat's saying. I started doing that, haven't I? Yes, I have started doing that. But I'll show you the testing of it in a minute. This breadboard, I got that from AliExpress, I think. I got it from AliExpress. Yeah. Yeah, got it from AliExpress. So this lot here, all this mess of wiring up the top, that's for the Datron displays which I designed. The replacement display modules. I just someone inquired about one of those the other day. But they're worried about price, so you know, we'll see how that goes. But yeah, that's that little LED module I displayed. I designed before when I had that 1062, which had a smash display, and I designed that replacement display module for it. So that's what that's for us for doing that testing. So that bit there stays intact. That never gets pulled apart because that's used to test those displays. I really need to put that onto a proper breadboard or something. And this is just garbage, just bits and pieces of junk. Don't worry about that bit. And this is obviously just a regulator here. I was just tweaking resistor values, trying to get the result I wanted. So this board's actually got a 12 ohm resistor here, and the one I've actually set on was a 10 ohm in series with the output, just to soften the current a little bit. But yeah, that's what I was doing, mocking this up. And I did actually have another regulator next to it originally, another 337 to act as a current limiter. I actually had that on the board as well right there, but I stripped that out and we used it in this board because I decided I didn't actually really need it. It was working okay without it. Right, so like I said, this is charging this battery right now. What I'm going to do is take the battery off it and show you the output using the electronic load. So you can see the floating voltage is about 14.7 volts. Hope you can see that. Hope it's big enough. I should do camera shots as well because I'm going to record this video, don't I? So should we do camera shots of this too? I could record the video, but I've had problems with OBS sometimes losing footage, so I don't trust it for that. I rarely do it, only if I check it straight away. The chance of it losing it is unfortunately too high. So I've disconnected the battery, and now you can see the readout from the voltage. It's 14.7 volts maximum for that regulator when it's got no loading on it whatsoever. Alright, now I've got this set to constant voltage mode, and if I turn this on, so it's limiting to 7 volts, which is basically the top end of this battery charge rate. Bring it over to say 7.1, that's actually the actual top end, 7.1. That's only doing less than 2 milliamps draw. Right, so if there's that battery voltage reaches full capacity, it's going to be putting almost no power into it. Now if I drop this down, I'll stick 1 volt at a time. 6 volts is doing about 50 milliamps, which is the normal battery voltage. 5 volts, which should be the minimum voltage the battery can produce, but it's basically flat, should be 5 volts because it's got 5 cells. And that's 123 milliamps or so. Okay, so the actual range that this is offering is quite good. If I go down lower, say if I go down to 4 volts, it's doing like 300 milliamps. But the most this circuit can provide is about 250 milliamps, I think it was. So I'm not too worried about that part. I think that's pretty good. Oh dear. Bloody cough today is annoying me. Okay. So like I said, that mock-up was on the board here, and I basically replicated it on this breadboard. And the only difference between that and this is this resistor here is 10 ohms, and here it's 12 ohms. And that just gives it slightly more current, not much, it's a few milliamps. So with this board, I've already done testing on this one, and at about a 7.1 volt mark, it's doing about 4 milliamps. So I think that's still a perfectly acceptable trickle charge rate for these batteries. And the chances of this thing actually being left on power the entire time anyway, it's like 0. So I'm not actually too worried about that. I just wanted to get the lower charge rates just a little bit higher, because it did make a difference to that. Just so it does charge quicker when it's initially powered up, because when I use this Keithley, which this thing's going into, what will likely happen is I'll be using the thing for a few hours. You know, I might have it plugged in for a day maybe, and that'll be it, and I'll put it away again. That's likely how I'm going to use it. So this battery needs to have a decent charger on it so I can charge at a decent rate when it is plugged in, and then not necessarily fully charged. Not worried about fully charging. I mean, it would be nice, but I'm not overly worried about fully charging the battery, as long as it's got a decent charge rate going into it, so it does kind of top it up, and without overcharging. They can tolerate overcharging a little bit, but you have to be careful not to overdo it, because you will damage them, because they end up producing heat and stuff like that. But they're actually slightly less tolerant than ICADs from that point, but I think this is a better battery long term anyway. Right, that's enough wobbling. It's got the thing in there. Self-hosting your sites, yeah. I mean, I would love to self-host my own sites, but unfortunately the reality is my internet connection is not good enough. It's just not fast enough. When I struggle with live streams half the time. So I've used various providers in the past. I had one guy I actually got quite friendly with, who owned a company. It was a company called Parcom at the time, and they were quite good. But he sold the company, then it kind of went downhill from there. And I changed a couple of times since then. I changed again. Well, I changed one of the sites last year, because the hosting company changed their system. They did an update. It meant I couldn't actually access my database anymore. Like, I couldn't use PHP admin. Couldn't access it. Couldn't log into it. Couldn't get the data. And that's something I had to do every week. So, yeah. And it took them about a month to fix that. By the time I fixed it, I'd already moved the site onto a new server, because I figured out a workaround to get around the issue with the inability to access the database. I used PHP to access it instead, and dump it myself, and then recreated it. But I moved the site onto my own hosting system, because I've got I use reseller hosting, and so all my sites are on this reseller hosting thing. And it means basically each time I want to create a new website, I just dump it on there. It doesn't cost me anymore. I've just got this one plan that does it, and I just, monitor it myself and manage it myself. But I still obviously have a host which is in control of what software is running on the server, and when they do updates, occasionally it does break things. But they are actually pretty good, and actually I can just roll things back, and it's not usually such a big deal. But yeah, relying on other people's hosting systems, it's never great. As soon as you change something, because backwards compatibility, I noticed that's a lot. It no longer seems to be a thing. So it used to be, websites are built and design was done, so it was backwards compatible. So it'd always work. But it seems that in modern days, I sound like an old bastard now, don't I? Sound like an old bastard. Anyway, backwards compatibility seems not such a focus. It's all about development and new things and what's new and shiny, and not so much about keeping the systems at a point where older existing stuff still works. That's why you get those breakages when they do an update, because backwards compatibility isn't even considered anymore. They just, oh no, we don't need that anymore, delete that bit, put the new shiny code in there. Yeah, that seems to be the way it's going, which is annoying. Anyway, right. To hire someone to help move it. Yeah. It can be quite complicated sometimes. Reckon my 90's moving, do you? I suppose I could spin it around a bit. It's probably not facing towards me. It's probably a part of the problem. That probably helps slightly. 900. Well, yeah, well, I'm on, on a good day, I'll get 50 megabit up. 50 megabit down and about 20 up on a good day. At the right time of day. Usually it's more like 30 and about 10. That's the best I can get here at the moment. I did consider Starlink, but that ended up being what I said, it seemed to be a bit unreliable. When it worked, it was really fast, but there's lots of times where you get complete outage, and it's like, well, I don't want that either. So, and there's a lot of money, so yeah, I left that. Okay, let's pull this apart. Turn that load off now, don't need that running. Okay. So here's the resistors I purchased. These are from Element 14. Yeah. I think these were 0.1% resistors. I forgot what the original ones were now. I think they were less than that. I'm pretty sure they were less than that. Give me a second, I've got to blow my nose, which means I've got to mute this thing because you don't want to hear that. Right. Go as well. Now, I figured out where I'm going to put this board. So I might take this cable off to get it out of the way. So I find some tangled with the power cable. I think it is. Well, this actually does both. The reason it's called a micro ammeter is because it does both. It's got two modes, amps and volts. Yeah. So amps, and you got high impedance input, and it also got 100k input as well. And it does 100 millivolts. Sorry, one millivolt. Bloody hell. 1 volt or 1 milliamp, I suppose, because it's 1000 microamps, right down to 0.3 nanoamps and microvolts. So that's what it's capable of doing. And it's that filter which is on it, need to modify as well, because that's currently set to 60 Hertz. So that is changing. But yeah, I mean, it's not a piece of gear, but the fact it can go so low in levels, that's why I want it. I don't have a particular use for it. Nothing in mind, but there's been times I need to measure stuff at low levels, and having something like this might have been useful. Makes sense now, cadmium, yeah. So the cadmium solder is stored just here, the sun just there, because the resistors will need a changer in here. So we've got a carbon composite resistor just down there next to the capacitor. Right, just there, that is changing to 1K. And these are the two position resistors got to change. And they're on Teflon standoffs. So, yeah. These are 0.25%, I think. I think it's 0.25%. I'm going to be putting 0.1s in. But the reason I've got two different types, because I wasn't quite sure about the tolerances of these, because although these are decent resistors, they're not as decent as those, I suppose, I don't know, but this is 1.27k. The part it's supposed to put in is 1.273k, right? So it's 3 ohms higher, which made me think about getting these ones instead, which are 2.55k. You halve that, you're getting a bit closer. So I was thinking if I put two of these in parallel on each post, that would get me closer than putting in one of those. But it's going to be a bit messier. I'm not quite sure how critical it is, because it is adjustable. That's what this trimmer's for here, for changing the filter. So that type might be close enough. So I've got filtered. You've seen differences. Okay, so look at this. I'm just reading this now. So normal solder is 20 to 30 nanovolts, and on cadmium you're getting 0.5 nanovolts. That's quite a big difference, isn't there? Be careful soldering cadmium stuff. Well, I do have a filter here. A little, well, kind of. It's not a great one. Maybe need to do something about this battery. Another project I need to sort out. Let's move these out of the way for now. I've got my fan here, which I'm going to have to make sure is close enough. So this is extracted and filtered at the other end, but this is one I built because I'm a cheapskate. I do actually want to get a proper one. I do intend to get a proper one day, but I haven't got there yet. So I'll definitely be using this. XPTF56, I'm not quite sure what that is. Yeah, well, these caps are probably fine. I mean, you just got a special tip you use with Cavian. Alright. Okay, well. Yes. So do I do double up the 2K55s, or do I use the 1.27s and hope they're close enough because they're only 3 ohms out? I'm inclined to go with these ones myself, but yeah, haven't decided yet. Well, but let me get there. Let's do the power supply thing first, then we'll tweak that filter. Now, I actually had a look at this already, this filter, and I can get it out without taking the wires off, which is quite good. There's 2 screws, and I actually already taken those out before, and just lifted the board up enough to make sure I can get to that resistor there. And there's just enough movement in the cables to allow me to get to that resistor, so I can desolder that one down there and swap that one out. Obviously, these ones are easy because they're on top of Teflon standoffs, so I can get to those without any trouble. So yeah, that's easy enough. That one there is a bit of a problem. But yeah, I don't want to mess with that board as little as I can. I want to try and leave it as long as much as I can because it is the input board, and obviously sensitivity is important. With PTFs. Alright. Oh, right, so you've got no contamination from cadmium and other stuff. Alright, okay. Well, I mean, I've got a limited number of tips, and I'll probably use some generic tip. I don't know. This one's pretty ugly, I might use that one. Yeah, I've got gloves sitting here, over there. I've got a bag full of gloves there, so when I go to do it, I will be sticking the gloves on. Yeah, so what I've got for this power supply, the plan, I need to take these little legs off it again yet. On this PCB here, I should probably record a video about this so explain to everybody else when I do the video. Let me just get this right. And you've all gone blind temporarily. Here we go. Camera's had enough, had a break. Right. Wait for the monitor to turn back on again so I can see what I'm doing. So the placement for this power supply board, I've got it figured out already. So if you look at this PCB from the bottom, you've got 4 holes here. Obviously, ventilation for the individual battery, I'm guessing that's what those are for, because the battery used to be above this circuit board. So they're trying to allow for some ventilation, I'm guessing. I don't know. Or some mounting system maybe. But you've got 4 holes there, which is great because it means I can stick a bolt through. The top side of the board, there's nothing in there. That's where the battery used to be. Right? So I'm actually planning on just popping this board here out, which is the power supply board, and we'll bolt this in directly onto that circuit board just like that. And just run some wires off it and run to where we need to go. So what I've got to do is modify it up here. Try and get a shot so I can show you. So the connections I need to make, just like a bit of focus. So the connections I need to make are down here. Got a big resistor here, that's a 56 ohm resistor. So on the bottom of the switch we've got 2 diodes which come across, you can just see the little Teflon wire, whatever it is, over there. Anyway, there's 2 diodes come down here, they join together, run to a wire which runs around the back of the switch using it as a mounting system onto that end of that resistor. So that's where the AC comes in, is here. You got a series resistor, which is what normally limits the current to the charging battery. That's then got a wire link that comes across to these switch contacts. This is the battery connection here. Right? That 100k resistor is used for the meter, for testing the battery level. So what I've actually got to do is cut right there. on that wire right there to separate that resistor from the battery. I need to inject the charging circuitry at that point. So that means then it will feeding AC in, going to the charging circuitry, coming back, and then going to the battery. Now, I don't actually have to bring a wire all the way back. I don't know where that wire goes at the other end. I can actually trace that out. I know where that goes to. So I only really need to bring one wire up and connect it to this point just here, where I'll cut it. So I'll cut it there, and I'll connect the wire to that. And that'll give me my AC input, which will go to the input of that regulator circuit. And then I can then tap it off to where I need to go, directly to the battery end, which is over there. There's the battery terminals there. Okay, so the black is the negative side of the battery, which is actually minus 6 volts, and the white is 0 volts, just to be confusing. Yes, so the DSLR I'm recording through, I also got hooked into digital streaming, so I can record actual footage for the video, because I will, when I'm working on bits of gear, I like to record a proper video for it. Not many people watch the live streams, you know, it's a much smaller proportion of people compared to a proper video, so I'd actually, you know, get all these relevant bits in the live stream, hopefully not forget to push the record button, and then I'll compile that into a proper video, because I've already recorded a bunch of footage on this already. And this will be, I think it's part 3. I think it's be part 3 of this particular unit. So the first part's we're repairing it and getting it working. And obviously now the final bits are just putting the battery in there, and so we can run up a battery supply, so then we can get those really low level measurements, because we can't get those right now running for AC. Obviously it's too noisy, so which is why I need to get the AC supply removed from that and allow the battery supply to be used. And you know, I could have potentially just chucked the battery in there and had it work and be okay. But the battery charge voltage from this thing is like 30 odd volts, limited by that resistor, which is why I didn't want to really use it as is. I wanted to put a regulator in there to tame that down a little bit. I mean, maybe I could, you know, it's true, I could, you know, pick and choose these ones, but these are 0.1% tolerant, right? So the actual variance on these isn't going to be very big. And I've got 10, but the chances of actually finding one which is towards that 273, not likely. Not likely at all. You know, worst case, it's probably going to be 271, pretty much, and that would be it. So it'd be slightly closer. So it's certainly a possibility. Anyway, so I need to get these wires off here, and we'll get it wired up and mounted. Pop this power supply board out because it's in the way. Don't need that in there right now. And it, yeah, you can see where I'm planning on mounting is those holes there. Plenty of space. And I'm actually going to mount the battery on the side over here. I'm going to I had double-sided tape over here originally, and I'm going to do exactly the same thing. Because the wire lead's only this big, and I'm just going to shove that down there somewhere, so that wire will reach probably just like that. Something along those lines anyway. And just cut that plug off and wire it straight into there with some ferrules on it. And stick it in. So yeah, that's the plan. Probably use this since I've got it sitting here. Actually, I really want to go to the wires for now. I strip these off. Come on, fall off. Might need a bit more heat. It's a really small tip, this one. Right, so I need some wires, which will be long enough to go to where this is going to be mounted. And so the wiring for this transformer and these connections are all actually under this transformer down there, right, on the main board. But obviously I can get to them from this side. So those connections are down here. So the ones for the battery were those two there, I think it was. Just there. They go from there across to this side. The actual front panel ones are on this side. They sort of cross over. It's a bit strange setup. Don't know why I did that. A broken EG&G 113. I don't know what that is. You do some bit more. Well, you do a lot more advanced stuff than I do. I'm somewhat jealous of your lab setup, I have to say. There's some awesome stuff in there. Right, so I need to get some wire and figure out what. I mean, I could wire down to this end over here for 2 wires, I think. I haven't figured out that bit completely yet. I had a concept in mind, and I need 1 wire coming up to the top. I definitely need 1 wire going there, so that's not a problem. This is where I do the other 2 wires run coming back up to here, so I've got a pair, so it's a bit more obvious about what it's doing. And then I've still got to do the 0 volt tie-in, because this is a negative supply, so it runs off the negative side of it. It's done a negative switching system. There's also got a fuse holder over here which goes to the battery, so I need to tie in before that fuse holder. I could tie directly onto the fuse holder. That might be an option. Yeah, I'll put a diagram up, you can see what I'm talking about. Might be a bit easy for you to understand it. It doesn't need heat sinking unless it's got really high current going to it. So when I'm running 100 milliamps, I was doing testing on this before. 100 milliamps, that was getting warm, but not so bad as a problem. So I'm not actually too worried about it. And I'm thinking bolting that to the PCB will provide some kind of heat sinking as well. You know, it won't be much, but it'll be some. Oh, preamp, okay. Alright, let me show you the diagram. Top screen, here we go. So this is the one which I scanned in. So there's the AC input, obviously. Here's the half bridge. There's that big 56 ohm resistor on the side of the switch. Obviously there's the switch. There's that linking on those posts. And then it comes through the switch and it goes to the battery terminals, or goes to the fuse, to the battery negative. Obviously because it's a negative. And then also the power taps off from that point as well. So that's also coming from that switch. Now as you see, there's no smoothing capacitors in this section at all. So it's purely, you know, half bridge, no DC rectification as such. Well, it is DC, but it ain't very smooth, that capacitor in there. It relies on the battery to do that smoothing. But when you come down past the switch section, it comes down to this point, and you come back up here, you got a 500 microfarad cap right here, right? So this is all negative side switching stuff. It's got a common positive. So yeah, that's the bit there. So I'm working on the negative side, which means things are all kind of backwards, which is a bit against how I normally think. Yeah, I don't want to drill holes in the case if I can avoid it. I mean, I could mount it on the back panel. Mount it on the side panel is not possible because... should I get rid of test controller now? I think I can get rid of test controller now. and it's going to keep it there, is it? It is going to keep it there. There we go. It's going to keep it there even though I've closed it. It does that. I could just hide it, I suppose. Anyway, yeah, it's cutting my face off, so let's do that. So, I've forgotten what I was going to say now. So yeah, because it's all negative side, it's all a bit confusing, you know, working backwards. I don't like working on negative side of things. So obviously I've got to cut into here where that resistor joins on, and that's when we're going to insert the regulator just here. So because at that point there, we did the testing previously, it's like over 30 volts. I think it's about 36 volts or so. And when it's loaded down, it's drawing about 250 milliamps, if I remember rightly, through that resistor. So that's how much it limits to. When you drop that voltage down to 6 volts, it's about 250 milliamps. So that's like the most current it could possibly be, which is why I'm going to put the regulator after that resistor. So that helped buffer it slightly, and having the capacitor after that resistor has obviously helped with the smoothing effect as well. So, yeah. Yeah, the batteries use the crude regulator, so yeah, obviously I don't like that aspect, so I wanted to, because it potentially could go to 30 volts. It just keeps on chucking the power in, which is why I wanted to tone that back a bit with the regulator. Because the instructions say don't leave it plugged in for too long in the instructions, so I want to avoid that in case I do leave it plugged in one day and end up melting the battery or something. So yeah, that's why that is done that way. But yeah, injecting here is where I have to go. So the injector regulator is going to be put in series with that section. And then we've got to put the common positive, which in this case is going to be the 0 volt rail, because this is a negative rail. So it needs to go 0 volt for the regulator going to this rail here. So that's what I mustn't get mixed up. Yeah, the PCB is not going to do much, but it doesn't need to do much. Even at say 100 milliamps, it wasn't getting that hot. I mean, it's warm. You could touch it, but not for very long. You know, it's like 50 to 60 degrees. So, I mean, I was thinking maybe I could maybe tie a piece of aluminium heatsink to it or something and bolt through that. I do have some bits of aluminium heatsink. I don't know if I've got one which will fit on it though. It did cross my mind as well. Is to put a heatsink on it and then bolt both to the board. Oh, okay, very similar setup, is it? Right. Yeah, I don't like that. I mean, it's why cut that corner, you know? Anyway, I could have chucked the transistor regulator in there and it would have been done, you know? Get crystals, yeah. No unit stage, yeah, indeed. I mean, this unit had the battery removed already when I got it. It was something already taken out, and obviously realised it was a bad thing. Or maybe it's already failing, I don't know. But it works without it to a point. Anyway, let me have a quick look for heat sinks. I mean, I would prefer to put heat sink on it. I have to see if I've got something suitable. Let me have a look and see what I've got. It wouldn't even need much. Just a piece of aluminium plate. And I've got a piece of aluminium plate like that. Just an L-shaped piece, which is a bit ugly, but I've got a little plate like this, angle plate. You put it down where you can see that on camera. Probably can't really. You can see it all, probably not. But yeah, I've got this little piece of L-shaped angle plate. I could probably use that. That'd probably be good enough. I mean, there is not exactly much airflow inside the unit either. I need to sort out screws. It's quite a long screw, probably way bigger than I need. Nuts. I'm going to put a mica, not a mica, a washer on it anyway, like the plastic washers that go on the tabs. Put one of those on anyway. So that's the bits I need for that. So there's a little aluminium plate, L-shaped plate. That should be good enough. So we've got a hole in it for a part. So yep. And I'm going to need to wire, which is what I originally thought about getting over here. I must be waffling a lot because my camera keeps turning off. Right. You replace the batteries, but it's still very dead. Oh. Hasn't blown the diodes, has it? Do a live stream tomorrow. Well, for me, tomorrow's Monday, and I'll be at work. So if it's this time of day, I'll miss it, unfortunately. Obviously, I could always go back and watch it later on. It just means I wouldn't be had to be part of the stream. Wouldn't be able to join into it. Let's check this. Okay. Do it that way around. That should be alright. A bit of stuff on it. Yeah, I know you can't see what I'm doing right now. Don't worry about it. It's not exciting. Scraping off some adhesive to get a flat surface. Okay. Right, so I've put together the bits. So we got a little bit of heatsink here. I was on the fence about whether or not I needed to put any heatsinking on. Doesn't really get that hot, but it's probably a good idea to put a little bit on anyway. If it does have a situation the battery is very flat, it could be drawing 100 milliamps, and so putting a little bit of heatsink on to kind of help it slightly. But even 100 milliamps, this could tolerate it. This wasn't getting that hot. You couldn't really hold your fingers onto it, but it was, you know, you could touch it briefly, and the actual device could handle that. So I also got a rather long M3 bolt here and a little top hat thing, I suppose you can call it, which goes through the TR220 like that to insulate it. I mean, purely just as a spacer for the bolt, although that seems to be awfully long. Sticks out the back of the device. Might trim it down a little bit. It doesn't actually need the insulator in there, but it'll probably be just helpful to get things aligned and just to make sure it's all sitting nicely, because the piece it's going to be bolted to is insulated anyway. It's not exactly mounted onto a chassis. I mean, I could mount it to a chassis, but I'm not going to. I'm going to put it straight onto the circuit board with this, and that should be fine, I reckon. Live in the wrong time zone, yeah. Marco's got more energy storage, yeah, probably. Anyway, so this needs trimming down, so I should probably do that. I don't know if I can do it with this one, we'll show it. Yeah, it's cutting fine. Done. So I think think I should probably mount that to the heatsink and get that bit done. Oh, I can't because I bolted to the board. I can't bolt to the board to get the wires on. So, the 3 wire colours. Black is going to be 0 volts. Brown will be the input. Orange will be the output. That makes sense? I do tend to try and standardise the way I work with wires to keep things predictable. So I look at a wire cone and go, oh yeah, I think I know what it does. You tend to try and standardise what I do with these. Oh, that's torn. Let's pull it straight through. Oh. Now, I want to go from the output. Now, do I go back over to here with the output, or do I go to here? I think I might go down to the board where these wires come in. Don't forget this is a negative side. So I have to retrace that wire. I think I'm just going to go to the board with this one. I don't have to waste wire either, that's the problem. Anyway. So that's the output one, which is going to go here. It should go through the holes on the PCB. It normally does. There we go. Just fits. I'm about recording a video about putting the wires on. Should be right that interested in that part. Come on. Got the sitting here, I might as well turn it on, eh? I think I should probably change that tip, but it was a bit small. So that's that one. Now, the input, which has to go quite a distance. So we go to there, down, to sort of there, then across to sort of out there somewhere. In this case, I'm going to cut it slightly generously. Hopefully that's enough. It's probably find it's like half an inch too short now. $3245 repair day. Is that modification you're doing? I actually looked for those things, see if I could actually maybe buy one. I end up getting something different. You'll see that in future. You guys don't know about it yet. So this is input, which needs to go to there, which I think I have solder going across. I do have solder going across it. So I picked up a Keithley, what the hell is it? 228 is it? I've forgotten now. I think it was a 228. Four quadrant source. And it actually works. Only there's a minor problem with it. Seems to work fine. Anyway, testing I've done so far seems fine with it. So that's all quite nice. (24.1.3 meters). That's a nice deep bench. This one, this desk here is 600, and it's not enough. I mean, I've got big gear which turns up. I can't fit on the desk, and I've got a repair sitting over there on the floor, which needs to be done. I can't even fit on the desk. I'm not quite sure I'm going to do that one yet. Anyway. And this negative one doesn't need to be as long. So I reckon I'm going to stick that on the board itself. Probably down there somewhere. Or up there somewhere. Or potentially going straight to the socket, so let's do that one. We'll call it negative. It's not a negative, it's a 0 volt rail. It's negative side, so I need to keep changing my terminology because it's not right. So I'm using these to strip the wires off, right? But I do actually have a proper wire stripper sitting right here. I don't know why I'm not using this. Come on. Really should change this tip. Right, that's the wires in place. So how long is that input got to be? So I'll cut that off. I think I might mount it that side more. Maybe. Go there. Fluke calibrator is quite a bit bigger, is it? 9.6, yeah. Is this 60 or 90? Oh, well, now I'm thinking, actually. I think it wasn't 60, I think it was bigger than that. Hold on. That's 800. 800 at front of this, so I do actually have a back. I think these are 700 deep. I do have a small gap at the back. So that's almost 800 at front. Yeah, they're not really deep enough. Alright, let's get some thermal paste. Record some more video, shouldn't I, really? Right, so I've got the wires on the board here. They're roughly the right lengths I need. I'm probably going to be cutting some off to waste a bit of wire. Don't like to waste wire, but sometimes it's just necessary. And I have just noticed I've lost a piece. There it is. I need this bit. Now this bolt is massively too long. It probably won't matter. So I was going to mount this to the heatsink, or poke it on the heatsink, then shove it into one of the holes in the PCB, and hopefully it'll be good. Now I've got to do it this way around, unfortunately, but there's still enough coverage from the actual heatsink part of the transistor. I would prefer the other way around, but it's a bit close to these other parts, so it's better to do it this way. I'll shove this in. Now, the only thing I might need to do is put washers on this bolt here, on that nut, because the holes are quite large. So I'm going to need to grab some washers. Yeah, I'm just going to stick it right there. Grab some washers and I'll come back. Typical gear in the house, you're in trouble here. 630 deep, yeah. Right. Washers. I'm sure I've got some. Yes. Haven't opened them yet. Well, you've got some spring washers too. I should use those. Just to make sure it doesn't come loose. Also not opened yet. In 3. Sort of star washers. Since you've got plenty of bulk there to work with, I might as well use them too. Might help. And M3 on this one isn't bloody marked. I'm guessing it's this one. Now, do I need to use 2 to cover these holes up? Potentially. Let's have a look. I think I might. I might stack a couple. Just to be sure. Don't want to damage the circuit board. Got 4 underneath it. It's quite a stack up. Okay, well, thanks for dropping by, Ilya. Catch you later. You have to watch out for your stream when you do it. It's really close to that track, which I should be able to avoid. Let's see how this goes, otherwise I might have to use a different hole. Because obviously the heatsink and this bolt, well, the bolt is actually insulated, but the heatsink is not. So if it's touching the heatsink, then it could actually end up being a problem for touching the, I think the input is on the heatsink, on the tab of the transistor. Well, so I see it. So let's watch out for that. I think that's alright, it's well clear. That should be fine. Let's get a nut thing to go on there. Nut driver to fit those nuts. Is that it? Yes, it is. First one. I was lucky. Let's check the other side, make sure it's all looking alright. Yep. Cool bit of video doing this, I suppose. Right, just mounting this in here now. Got a nut driver that fits beautifully, so that's all good. Okay, so compress down. Just make sure it's not touching that track. Yeah, that looks fine off the way, that's fine. Happy with that. All good. Now I need to wire that in, so it's got sitting just there. You see it. Anyway, so we've got these looms running around. I'm going to try and get it into one of these looms and at least follow the loom around and come up with it. I'll try and thread it through if I can. I mean, all these other wires are all Teflon, so it's a bit of a downgrade. But it is what it is, I suppose. Just take this board out, this is in the way. Make it easy to work on. Try and thread it through the back of this lot without entangling it through the whole loom. Try and get it tidy at least, if I can. It's a little bit awkward. Look at that. Just about perfect. Now, so the output, I could do the same thing with the output, or I could run it at the other end of this wire, this orange wire, the original one, and go to the circuit board. I'll do it either way. I'm inclined to just go up here. Because those two both come down to here, so I'm actually, no, I think I might go through a hole and run it over. I think I'll do that. I'll go through a hole and run it over. So all the connections are down here anyway, so I might as well just go straight to them with those. I think that's just a nice way of doing it. Right. Let's figure out where those connections were again. I've forgotten where they were. Let's go from this one first. That's the battery side here. That one. Actually, no, I will do that one. Okay. Yep. So it's that one there, the top one. So let's check in for the actual terminals. So I'll go from the switch, which is the battery connection side of it, down to here, and that terminal just there. So I'll get back onto it. Switch slipped off. So that wire there, that top one of those, there's two connections there. The top one of those two goes to the switch, which is the battery connection. So that's where I need to put the brown wire. And I believe the one below it is where I've got to put the black wire. Let me check. A bit hard to see. That one there, I believe. Just double check. Trying to see what I'm doing here. Right. So the fuse here, on the negative side of the battery. So that will be the yep, that's right. So the other wire, other terminal was the one which needs to go to the black wire, because that makes total sense. So that one there should go to this one here. It does. So yeah, those are two connections I need to use right there. So that's fine. It's verified. Okay. Now you've got this main switching here, so I'll keep away from that. I might just go directly across rather than running through the loom, maybe. Yep, start off there. Right. Go and grab it. I'm going to change this tip because it keeps on annoying me. Hopefully the wires start to fall out when I touch them. Yeah. Which one's which again? Black one's the bottom one. Okay, we'll tie those over there once I'm sure it works properly. Just to make sure it's not touching on the back of these, because obviously this is the main switch here, I don't want it touching on the back of that. So I'm going to try and bring it this way and cable tie it over here with a bit of slack, so it's got some flex in those cables, keeping it all away. Oh, thanks Dave, catch you later. Right, well that in theory should work. I should double check, shouldn't I? One last test to make sure I haven't got them mixed up. And I also got to cut that trace and attach that orange wire, or cut that wire I should say. Yep. Okay. Alright, so now I'm going to cut this wire just here. I might be able to lift it off actually. See if it's wrapped or not. Might be able to lift it. Let's try that first. If it's wrapped, I'll have to cut it instead. It's wrapped. So we'll cut that right there. Make sure it's not going to touch. that is attached. So that should now connect to that resistor. If I go to the correct mode, it'd be helpful. Right. If I do resistance, I should be able to measure from one of these diodes over here to here, measure 56 ohms, NIN. So that's working. So I'll do a test and I'll tie these cables in and tidy them up. Get them all cable tied in nicely. Get them routed nicely. Okay, let's plug the boards back in here. Boards back in here. Also, you haven't got the battery installed yet. I just want to check the voltage on the terminals and see if it looks like it's working correctly or not. Right, let's get set up. Chaps that work on two PCs but do on a tablet. That's interesting. Is it a strange problem? Right. So, what do you reckon the chances are of magic smoke? What do you reckon? So with no battery in there, if I do battery test first, or battery mode, there's no power. If you go to off, it'll try and power it. On, obviously try and run. Right, so the charging circuitry is not enabled until it's in the off or AC mode. If you're on battery mode, the charge circuitry is not used. Just explain that again for the purpose of the video, shall I? Right. So this switch here, the charging circuitry on this thing's normally only active in the off or AC state, so there or there. Right. In the battery position, the charging circuitry is disabled. So I'm going to power this up initially with a battery setting, which means it should be dead, should be no power. And I'll verify there's no power coming out of that regulator, which I can do by measuring over here on these terminals. And then I'll go to the off state and recheck, and I should see that voltage of around 14 volts or so roughly, because there's no loading on the circuit, so it's going to be floating at higher voltage, and that will confirm then the charging circuitry is working. And then we can actually connect the battery up and see if it actually works. Well, I've got the probes in place. Turn the power on. In battery mode. Should be nothing there. That's correct. Ready for magic smoke? That voltage doesn't look right, does it? What's going on there? Same thing if I turn it on. What's going on there? Why is that voltage not right? What did I get wrong? There's always something. That's interesting. Okay. Well, Let's measure it down here. Actually, I wonder if I bridged a trace on that circuit board when I was soldering those wires on. I wonder if I've done that. Because I normally forget, I normally do check the traces for bridges on these things after I solder them because they're so easy to bridge. Let me check. I'll see, fine. So why is that voltage wrong? What's going on here? Check over here. I think the casing was common. Let's find out. Hold on a minute. Do you know what I've done? I've got the brown and the orange back to front. I've wired that up wrong. Plus I'm an idiot apparently. This one should be going the other way. That's the output, not the input. Yeah, that was stupid of me, wasn't it? And I cut that brown wire down now. Yeah, I was saying I've got it standardised and how well I tend to think things. Brown is input. That's the input. I've got it back to front. What's the best way of solving that? Swapping the wires around the board. It's just a bit awkward to get into now. Damn it. That was stupid. Why didn't you guys say something? You just spotted that. Also not paying attention. Dear. It's funny. There's a video checking AC volts of AC volts. Yeah, well, I've done it. So I've certainly done that more than once. Now we're trying to get these wires back through the holes in the push board. No, got solder on them and don't go quite so easily. Let's try it. I'll stick on the back of the board. It ain't going through. Okay, sod it. These wires are just a little bit thick. Once you've got solder on, I just don't want to go through the board. So I'm just going to shove it on the back of the board. Sod it. I might actually do is, like I said, get a proper board made. And once I actually have a proper board made, I might actually swap this out with a proper board. Maybe I'll decide with a heatsink on it or something, I don't know. Something like that, maybe. Right, we'll try that again. Maybe this time it'll actually do the right thing. So it turns out I'm an idiot, and what I actually ended up doing is the orange wire is the output, and I ran it through to the input side. So, so after me originally saying about having a standard about using brown for in and orange for out in these low voltage situations, yeah, well, negative voltage situations, I ended up putting them in places anyway. So I went to swap the wires around on the board. The regulator's probably still fine. These things have got lots of good protection inside them, so there's a good chance there's nothing wrong with that. So we'll try this again, and this time we should actually get, I think, 14 volts, like I said. We're getting 30 odd volts there, which is interesting. That should be regulating it. Have I blown it up? Maybe. It's not a short. I was expecting a much lower voltage than that. It's making me suspicious. Have I forgotten something? Yeah. Why am I getting 35 volts here? What if I blew that regulator up after all? I'll jinx it by saying it's probably fine. No, it's still dropping 2 volts. You've got 37 there. So it's not short, we're dropping 2 volts. Oh well, you might be alright. Let's hook up the electronic load. Put this onto it and see how it handles the loading. Found a power supply, didn't find the electronic load. Come on. It's not loading electronic load on display. That's great. It does this sometimes. So I'll do an on-screen display of it. How about now? No, no. Come on, talk to the bloody load, will you? I want to show up on screen. Well, it's not going to show on screen. It's not working now. So it can't show you the electronic load on screen. Should have left it all turned on, shouldn't I? It's working fine before. Right. Actually, I might try. If I turn the multimeter on, sometimes running multiple bits of gear at once will make it work. I found that before, it gets confused. Let's just try that first. I want to do the on-screen display of the load. I mean, it'd be nice to. I'm probably going to point the camera at it anyway. Let's try it one more time. Well, we found the multimeter, didn't find the load still. Nah, it's locked up. It does that sometimes. Communication issue. Right, well. So let's look at the electronic load whilst I power this thing up, and we will do testing with the load to see what the load thinks of it. And to see if there is an issue with that regulator in there, because that voltage is higher than I was expecting it to be. Alright, power on, turn it on. So there's a 30 odd volts there. So what I will do is I'll do voltage first, I think, yeah. So 7 volts, only drawing 7 milliamps, which is actually in line with what I was expecting it to be. Yeah, it's like 3 milliamps to 7.1, which is exactly what I thought it was going to be. That's exactly right, so that's fine. So I don't think we've actually got a problem there. 6.5 is about 42, yeah. So 6 volts, which would be a relatively flat battery, 82 milliamps, and 5 volts, which would be a completely flat battery, basically is 166 milliamps. Okay, I think we're doing alright. You know, 4 volts is 225. It's the most it will go to is 225. So that's fine. I think that's actually been okay. You know, so yeah, I think we're fine. So I mean, a fully charged battery is about 7.1 volts, and that's 4 milliamps. So that's absolutely fine. That's working okay. I'm happy with that. Let's hook the battery up. My tablet's gone to sleep. Both PCs work to fine on BitLooney's stream. That's what it is. That's the problem. BitLooney's stream wore your computer out. I mean, he was streaming for what, 4 hours or something, wasn't he? So that's what's happened. He's worn out your computer. He owes you a new computer. Because that makes, you know, that's complete logical sense. You can't disagree with that logic, can you? I suppose I should change camera view so you can see what I'm doing, right? Get some double-sided tape. I need to give this a wipe inside to get it so it'll stick. You're right, I didn't use a tablet on the stream. Well, there you go. BitLooney owns your new computer. You tell him. Yeah, I don't know. So this is only the first part of this. The second part is we also want to do the resistors. Just change that filter. Do you reckon it'll be enough? 2 strips? Sure, I'll stick a third one on there. Nah, 2 strips will be enough. I reckon that'd be enough. Right. So do I stick this in at the end of the wires? Yeah, I think I will. I need to get a drink. I'll be right back. Right, it's better. Okay. Got that because it's just quick and easy to grab. I actually recommend you don't drink too much of this stuff. Right. So stick this in, and I'll do the wires. 2 strips will probably be enough, I reckon. Is Ian trying to hide my soldering iron again? Every time I walk out the room, he tries to steal my soldering iron. I'm pretty sure Ian's got a better soldering iron than me anyway. He doesn't need my soldering iron. Let's see if we can get this in without getting it stuck in the wrong place. What's the chance of that happening? Pretty high, I'd say. Right, there we go. Hopefully that does actually attach. Yeah, seems like it's working. Right, so it's got to reach those wires to there. Right, should record a bit of video of this, I suppose. So I'll just attach the battery in there, a couple of strips of double-sided tape. That's now in place. These wires will reach that connector just fine. So I've got to take these wires off one at a time, put a ferrule on them, and stick them into those terminals. I don't know, maybe I should do it as a blade terminal rather than a ferrule. I'm not sure. Ferrule. I'm going to say it instead of ferrule. Not quite the same meaning. Blade terminal is probably better, actually. Like a Fluke terminal. Then I've got to do crimping. Oh, I don't like crimping. I'll never get a good crimp ever. Can I measure 1.21 gigawatts? No, no. Maybe I'll pour some V into it. I don't know. Right, let's get something. I don't know, I do actually have some Fluke terminals, but I just don't like to crimp them because I'm not very good at crimping. That's probably one of the things I'm worst at, is crimping things. I'm pretty sure I've got some in here somewhere. Nah. Well, yeah, somewhere. I don't know where. Oh, there we go. Okay. Fluke terminals. Before I get committed, I should actually make sure they're actually going to fit in the terminals, eh? Yeah, fine. We use those. Be better than a ferrule. But I can crimp ferrules quite well. We've got a really nice crimping tool for ferrules. That actually works really well. Who is it? So here's the tool I use for the ferrules. This thing here works really nicely. Does a beautiful job. I wish I could say the same for the other stuff. But I can never ever get these channels to crimp nicely. I've got 2 crimpers here, right? This one's too big for them. It's not actually the right size. It doesn't actually crimp down hard enough. Now with this one here, which isn't really the right one, but it does crimp them, but it doesn't do a pretty job of it. I'm sure I've got some more stuff here somewhere. No, that's not it. Okay. So this set here, which might do it. Let's try this one, eh? I'll give this one a go. Because I've never been able to get crimps done nicely, ever. It's just one of these things I'm just not good at. I think I blame the tools. It's always the tools, eh? That's right, isn't it? So, let's give it a go with this. 2.5, 4 and 6 mil. Well, these were 2.5, wouldn't they? Those are straight through, they're not different sizes each side. I don't think this is even the right one here. I might go for 4 first, since that looks like it's going to crimp pretty hard. We'll give it a go with that one. Yeah, that looks like it's going to print pretty hard like that, as it is. No, I'm not cutting both wires at once. That'd be stupid. I'm sure someone's done it. Looking for the data for a Euro thread to Acme thread. Yeah, I've got no idea. I just know of like metric, imperial, UNF. That's not the right terminal. I've already got one on it. Now, what do you reckon the chance of me getting this nice? I'll give it about a 5% chance. If I can even crimp it with this, it feels like it's struggling. Oh, Jesus. I can barely squeeze it. Well, yeah, these haven't got any colour markings on them. They've got sizes, but no colour markings. Well, as much of a mission as that was to actually crimp it, that was actually really hard to crimp, that one. It's actually done quite nicely. Might even say it's acceptable. It certainly was not an easy thing to crimp. That was really hard to crimp, that. Wow. Well, it's done it. Stick them in before I short them out. Okay. Made for uninsulated crimps. Yes, it is, I think. But it actually did a nice job, though. It's better than the other ones. Now, there actually are the dies in the set. I mean, these ones are actually marked. It does come with these ones as well. Maybe I should put these in. But one thing I did notice about this set, which made me sceptical of it, check out the colours on those. They're not right, aren't they? Because it should be red should be the small one, blue one should be the middle one, yellow should be the biggest one, shouldn't it? Because that's just the normal convention. Yeah, I don't know. Maybe I should use this one. Maybe I should put this dye in it. Certainly looks like it's got a better profile. Might work better for them. Anyway. Yeah, it's always the tools. Definitely the tools. Two red crimps, yes, I know. But that's what I've got. Right, let's put it back together. I mean, I have colours for sizes rather than for the polarities. Well, that worked as soon as I plugged the board in because I went to battery power. I was thinking, why is it starting up? It's not plugged in. Well, because the battery's working. Right, so it does work. Yeah. So yeah, this was actually a review. This other crimp set I just used, I got that one to do a review on, and the case arrived with a latch missing off it, and it wasn't in the case, so they sent it that way. You know, I suppose the thing with review things, they give you their slightly damaged stock to get a review done, and yeah, I don't know. But it does come with other dies as well. Let's have a look. I mean, it's got these other dies here as well. That is 0.5 up to 1.5 mil. Again, it's going to be these uninsulated crimps, and 0.25 up to 1 mil as well in those sets. And also got that set I just showed you. And I think there's some screws. Oh, there's another set here as well. Different profiles. So you've got all these different types. I don't know even know what half these bloody things are. I'm not a crimping expert, but these ones are a lot of the ones I probably should be using for these insulated terminals. But the marked one. Maybe I should just get some paint and fix that. Anyway. Send it box of 500 crimping tools. I don't think so. Jesus. I've still got capacitors on my desk now, Ian. I've still got capacitors there. Look. There's still some here. Haven't sorted these ones yet. That's funny. I'll blow the nosy in a second. Just get a bit out of control. Now we'll try and get this case back into my drawer. Just first. Alright. Ah, dear. To mute for a second. Okay. Okay, so that powered up off the battery, so that looks like it's going to work. Now we should test it, shouldn't we? Let's get the cable. Just do this first step, make sure it actually does work properly with the battery voltage isn't too low for it or something. And we shall clip this onto power supply. I think let's do something better than that. I think power supply is a bit much for it. Let me take a piece of shit crapping set off my hands. Really? I think I can fix it. It's got lots of options. I just thing is I don't really know much about crimping stuff. You know, it's just, yeah, it is what it is. Yeah. Try and tie this up so it doesn't get tight with things. Let's move this out of the way before I knock it over. Alright, we shall test with this. Right, do 1 volt on there, open circuit voltage, turn it on. This is running from the battery. Actually, I should record this, shouldn't I? Right, just about set up to do a test with running off the battery only. AC power is not plugged in. Got Ian Johnson's PDVS2 Mini here for the generating voltages, which this thing can check because this only goes up to 1 volt, and this has got enough precision for me to do the lower stuff. So let's turn the power on, battery mode. So it's starting up, sorting itself out. Battery test, what does that say? Just over 6 volts. Excellent, that's right. So this scale, because you do the battery test, it can go up to 10. I was actually originally contemplating putting in a 9 volt battery instead of a 6 volt battery. 6 volts what it originally came with. But circuitry could actually tolerate a 9 volt battery, and I was going to put a 9.6 volt battery in there, but it would have meant a charging voltage of about 11 volts. 11.2 I think it was, something like that. 1.4 volts per cell, which meant it would have gone off scale, which would have been a bit old. So that's why I ended up going back to just being the same as original with a 6 volt battery. So we are there. We're slightly to the right of the scale there. But let's put in 100 millivolts and see what happens. 1 volt range on voltage, hopefully. Yes, so 100 millivolts, we should go up to about there. Yep, great. So if I can zero this out, yeah, it's not zero. I'll have to look at that aspect, zeroing it properly. Yeah, there's nothing I can do there with that. Not in the 1 volt range, but yeah, so that's off slightly. But that is going up by about 1 volt, was it? So look. Well, 100 millivolts, I should say. Is that second line up? Second line up. That's working correctly. Second line up. 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 And second line up. So that's actually looking linear. So that's all working properly off the battery at least. That's good. So let's go down to a lower level. Let's do 300 millivolts. Let's do 100. Let's do 100 millivolts for full scale. So this should go full scale. Pretty much, yeah. It's going to be slightly over because we're not centered properly. We're not correctly zeroed. So that's second line up. That should be doing the same things before. Basically, every second line up or thereabouts. I'll jump 2 then. Must have done. 3. Let's do it again. There's 100 there, 200, 300, 400. Yeah, it's looking like it's all good even on that range. Yeah, that's looking promising. That's all good. Let's go into 10 millivolts. Can I do any zeroing now? Might be able to. Should be able to zero it now. I need to look at this calibration of this thing for these high voltages. Nice, so zero that. So now we're on 10s, so that would be full scale. And it is, look at that, just about bang on. It's got by 1 millivolt at a time. Also not allowing for any stabilisation time, but it looks like it's basically fine anyway. We'll be getting some parallax too, because the camera height is above the meter, so you're going to be looking down on it slightly. So as it comes over, we'll be looking behind the meter, so that's fine. That's all good. 1 millivolt. So it'll be full scale. Well, actually it's 0 first. Drop this down very slightly. So this is where I'm thinking this needle is slightly bent. I'm not going to see it on here or not. But you see the bottom 0 is on and the top 0 is off to the left. So I think this needle is very slightly curved. Slightly annoying. Alright, so it's got 100 microvolts at a time. You can see some bouncing there. Don't think I've got the casing covers on, so it's going to be allowing noise in. So it's actually sitting slightly below on those ones. Let's re-zero it. Sitting slightly below. But it looks like it's basically working okay for these. And it's off the battery, so the battery seems to be running it just fine. So this probably does need recalibrating. I haven't done the things like the chopper frequency. I haven't adjusted those. So it probably should be done. The other thing is right now I don't have this filter, right? So this bouncing we're seeing, filter may or may not help it. It has helped it. It's not bouncing as much now. So yeah, but I still want to change those resistors for that yet. Anyway, that's working alright. That's good. Happy with that. Stop recording. Here we go. Alright, that's good. So we've got to change those resistors now. And that'll fix that filter. So they have a 50 Hz filter. Take this back off here for now, get it out of the way. So we'll change those. This is a bit I'm not so keen on doing. get this fan closer. Can't just sort of get up here, sucking the fan right there, really. Need those fumes to go away. It's gonna be a tricky one. I don't think having a wedge like that's going to work. Kind of need the wedges in place. That's not going to be a problem for fumes. Let's see what I can do about that. Right. Well, I need to clean this tip off. So we'll get those ones out first. That's going to be interesting. Magic smoke, yay. Cadmium solder, apparently it's pretty bad for you to breathe the fumes in. So I'm going to try and avoid that. Stick some gloves on, because I touched something by mistake. Funny thing is the original filter, even though it's 60 Hz, actually doesn't work too badly even on 50. So even though it's not the right frequency, as you saw, maybe hopefully you saw, it was actually behaving quite well. So these resistors are significantly smaller than the originals. I don't know if there's going to be a problem or not. Hopefully not. But, these are quarter watt resistors. I can't remember what the original was. Let's have a look at the original one. What was the original one in the manual? Manual parts list. It was 140 something. These two, 147, 148. Oh, these are only quarter watt as well. Or so, 1/4%, 1/3 watts. These are very similar rating, but they're wire round instead. Yeah, so these are 300 milliwatts versus the 200 and something. What these ones are? What these ones? 240 milliwatts, I think it were. Might be 250. I can't remember. Yeah, so that's the original ones it's got in here, so I'll take out. So we'll take out those two and this one here. So 147, 148 and 145. They're the ones we've got to swap out. Interestingly, 145 has not got a 560 in there, it's got a 680. But that's a factory selected value. It does have 1060s in here for those two, but this one's a different value, which is interesting. So though I've got to put a 1K in there to replace this, that may not be good enough. But you can see this resistor here, it's only 10% carbon composite type. So it's not even a precision type, the one that's in there, so I don't know. Maybe they found 680 was better for that frequency. Maybe the capacitance is slightly different, and so maybe I need to do in a slightly higher value. Maybe I need to put in 1.1K instead of 1K. Don't know. I guess I'll find out. Right. Okay. So where things go horribly wrong. Got to try and get into there. And it's all wrapped around as well, isn't it? Of course it's all wrapped. So it's not going to be easy to get off, and it's Teflon standoffs. So I'm hoping I don't end up pulling the standoffs out of the board. So I might have to remove the wires first, then get the resistors off. Bit of a pain. Definitely is going to be a pain. Now, I would like to wedge this up here somehow. Maybe not in the way it's going to fall off, that's the thing. There you go, that'll work. Tweezers, fume extraction. What melting point this solder is? Maybe different from normal, I wonder. Okay, so here we go. Let's just record this. So I'm going to try and remove these resistors now for doing the filter. So this is cadmium solder. I'm not familiar with cadmium solder that much. I know it's a bit more dangerous. I don't even know what temperature it melts at. But fume extraction I know is important. At the moment I'm not getting much movement on melting it. Maybe it does need more heat. What I've got to do is get the wire out first so I can pull the resistor off. That's part of the problem. But even that's not cooperating. Oh, this is going to be fun, isn't it? Yeah. Why can't it be easy? Which way is that rat? I can't even see which way is rat. Should I get a bit of this and just see what it melts at? That's melting there. Here we go. Let's wind the wire off. Let's get the wire off. Even that's only barely melted. This stuff does not melt very well. Okay, now we're getting some progress here. Now, try and get the other end of these resistors off because it might be easier to get this end lifted first. Come on. This is not melting. This definitely does take a lot more heat. I'm currently at 430 degrees, which I thought would be enough. It's only barely doing it. Come on. There's one resistor lifted off. One end. Come on. Don't be a pain. This change is definitely happening now. Can't lift the bloody thing off. Why are they so hard to get out? Let's try and get to it, it's hard. Come on. Jesus. This is definitely a mission to get out. Right, one out. Wow. I'm actually getting tempted to bloody cut the leads off. Why is it such a pain to get out? I'm at the point now I'm going to just cut the resistor leg off because I'm kind of tired of trying to lever it out. Yeah, if they weren't wrapped around it'd be a lot easier. Right, this is wanting to get off. Yes. Wow. Those resistors might be the same again anyway. Not about heat point to them. Wow, that's a mission. Well, let's get the new ones in there. At least this will be easy to do. Let's check the markings. Yeah, it's 1.27, just making sure. Try and put it so I can see what the markings are. So it's not necessarily for me, but it could be for the next person. So they can see that it's been converted already. Well, I'm saying for the next person, but next person could well be me anyway, because you know I'm not likely to sell this anytime soon. I mean, I may sell it, but I'm not planning on selling it at the moment. Right, now I need to get some of this solder over here. I wonder if the standard flux I use is safe on this. Let's get this solder right here so I can use it. Not this one end on. And I'll drop the wire. A bit of pain, come on. Still get the other wire attached to it, but we'll work to that. One thing at a time, get resistors in. Differently this time. We all try putting the wire on at the same time this time. Might be alright. Let's give it a go. Okay. This is sort of being a pain to get done. I wasn't envisioning this much difficulty getting this solder. Anyway, that's that end done. Oh dear. Well, nearly there. Almost got the resistors done. Well, the 2 precision ones anyway. This is not an easy bloody solder to use. It definitely doesn't work as well as the usual stuff. Taking a lot more heat and that sort of stuff. Doesn't flow as nicely. It's taking a lot more effort to get this done than I thought it would be. Anyway, here's what it is. I'm surprised it's been such a pain. Really am. Anyway, just about there. Just going to give it a bit more heat. My presets and my iron. Well, hopefully that's that one. What a pain. Okay. Because those joints just look like they're cold joints. They're just weird. Even though I've got a lot of heat in that. Not liking the look of those joints. This looks like cold solder joints. Not really liking it that much. I mean, they're made, but I don't know. I guess it's the nature of that solder, is it? Maybe. Do I need to use flux? If I use that flux, I might contaminate the joint. That's the only problem. I'm not sure about that part. Anyway, they're made. Now I've got to do the solder resistor. Which may or may not be using cadmium solder as well. Let's get this board out and have a look. Is there flux in the solder? I don't think so. Now I'm thinking it probably needs flux, but I'm worried about contaminating the joint. If I put flux in it, is that going to mess up the fact we're using cadmium solder? I mean, it looks like it needs it, but I don't know. I've not used cadmium solder before, so it's a new thing to me. So we need to get to that resistor there. Get that off. Now, is this cadmium solder or not? I don't know. Might be standard solder on here. Don't know. Is that resistor out? That was easy. It's much more like it. I get a 1K. See how much like 1K this actually is. $986K. Sorry, 986 ohms. I mean, it's only a 10% part anyway. Maybe it's not that critical. Yeah. Let's find out another one. The big board has again. It's 987. It's very slightly better. I do have metal film in here as well as carbon composite, or carbon film. There you go, exactly 1K. Beautiful. We'll go with that one. For carbon resistor, I'm quite surprised by that actually. You know what? Look at that, exactly 1K. We'll use that one. Cadmium using jewellery doesn't have flux. Yeah. I don't think it's got flux in it. It didn't behave like it's got flux. I mean, you can probably see now, actually, I've got the board out, how those joints look. I'm not really happy with those joints. And these joints don't look very good at all, really. I'm tempted to put some flux on it. Right. This stuff, I mean, I'm sitting at 450 degrees right now. 450. You see it's melting, but it still looks like a dry joint when it's done. That one looks marginally better actually. Let's reheat it again. It just looks dry all the time. It just doesn't look like a nice joint. Just not liking it. Yeah, I've got the extractor here. It's right here. Yeah, so I'm thinking about flux, but I don't want to contaminate the joint because this is precision. I'm going to do it. Very good. Last chance to say no, don't do it. So a little bit of flux. We'll try it. Yeah, that actually looks a lot better. It's still going dull though, look. It does still look a bit dull, even though I put flux on. But it does look marginally better. The other two joints at the other end actually don't look so bad. It was just this one looks pretty ugly. So I think I'll go for that one. Yeah. I think I have to live with that one. Okay. I think it is what it is, really. Now I've got to do a set of resistor. It's quite convenient, the holes empty themselves out. Yeah, I'll clean it in a minute. Let's see if I can do this nicely or not without adding more on the bottom. Now I'm thinking this is probably cadmium here as well. We'll try it. Yep. I really hope this is worth the effort. Oh man, just to add the filter, 50 Hertz filter. A bit of bloody work after all this. Right, let's put it back in. Before I forget, I shall clean off my iron tip again. Got a sponge here. Right. Oh dear. Well, because we'll find out shortly if this actually works. I might need to adjust it as well yet, because it's got an adjustment there for the filter as well. So hopefully it's within adjustment range. It's in the manual to how to do that, but I probably won't do that on stream. I'll do that later on. Sit down and go through a calibration procedure on it, because I haven't actually done that yet. Solder back in again. Ready for the next person, which may or may not be me. just clean up. I've got this stuff everywhere right now. Let's get some space back. My tablet turned off again. Now I was getting these off, they were not easy to remove. Yeah, the thing was that, well, definitely overheating those resistors when I was trying to get them back off again. I bet they've changed value now. Remove the gloves because I've been touching that solder. I'll do other things. Right. Drink. Let's test it out. Without adjusting anything. And you've all gone blind again. Probably means I've forgotten to record video when I should have done. I should mention that, shouldn't I? Okay. Right, so the resistors changed, that's those two there done, and that one over there has also been changed. I didn't really like the surface finish of the flux, and I didn't really like the surface finish of the solder on these, so I actually put a little bit of flux just on this one. It did seem to help it slightly, but I'm worried about contaminating the joint. I mean, the whole purpose of using this cadmium solder is that it's a better joint. But yeah, there's a bit of a mission trying to solder these things, but it seems to have gone, so fingers crossed it's actually right. We should retest and see if there's any noise, any bouncing with the covers off. Twisted, haven't I? Okay. Well, let's turn this thing on. I've got left on 1 milliamp. Sorry, got left on 1 millivolt. This is currently off. We'll put it 1 millivolt on there as well. Put on battery, and we'll see if we see any bouncing like we were seeing before. I'll turn the filter off, give it a chance to warm up, and we'll try it out. Okay, it's just about on 0 now. So we'll inject 100 microvolts. Let's get closer. Not seeing any bouncing there, and that's with the filter not turned on yet. So when it's a higher voltage, I'll see the bouncing more, maybe. But it's still working at least, that's something. The input's still good. Let's go lower. Which is 0. I'm seeing a little bit of bouncing on that. Very little bit of movement. Tiny little bit. So we are getting some fluctuations, but I don't have the covers on. Now I'm going to turn the filter on. Still got a bit of movement there. Don't forget, it's not adjusted yet. The filter isn't adjusted. So it's moving about 1 division there. Turn the filter back off. So it certainly seems more erratic without the filter. With the filter it does seem more stable. Not a lot on it. Like I said, the filter does need adjusting, so I have to figure that out. It's in the manual. Yeah, it definitely moves less. So we're on the right track, I think. Keep smoking, yeah, well. So look at these resistors here. See what these measure as after the torture I put them through trying to get them out. (1061), 1062, (106). Oh, bad connection. 1061. Oh, don't lose it on the floor. I'll never see it again. Oh, where'd it go? It always amazes me when I drop things on the floor. They often just literally vanish. Where'd it go? Seriously, where'd it go? It's gone. I still need to do that shirt. The Floor of Doom shirt. I've got an idea in mind. I just need to try and do the artwork for it somehow. Yeah, 1061-ish. So there's a 0.25% as well, so that's in spec, isn't it? Even though I tortured the thing getting it out. Anyway. But right now, people, like, this thing's running off battery. It's not running off an AC supply. Which is part of the things I've been doing this morning. Where the hell did that resistor go? Wasn't finished measuring that. That's just crazy. Unbelievable, it's just vanished. There it is. Okay. Try this again. This time I'm going to stick a probe through that leg. Try and hold it. 1061. So, and flicking down at 1060. So they both still measure kind of right. But yeah, they went through a bit of a torture test getting them out of the bloody thing. Right, chuck those in there, my random bits. Right, it's bloody noisy. Probably should put the covers back on it, shouldn't I? Do a proper test of it. So again. Let's do 5. So the filter in and filter out. There's not a lot in it, is there? Like I said before, the 60 Hz filter actually wasn't doing too badly in itself. You can see a fluctuation there. Put the filter back in again. I mean, the filter definitely is helping. There is definitely improvement with the filter, but like I probably need to tune it. So with no input, you can see it moving around there. No filter. Yeah. Yeah, filter's definitely helping it. And it's still accurate. It's good. Happy with that. It's working. Brilliant. What do you want to say, Friday House? That I'm capable of messing up more than once. That's entirely true, actually. I'm quite capable of messing up more than once. Right. Okay, that's good. That's working fine. So I think I can say that particular project is basically done now. I can put it back together. What am I going to do with it? That's the question. Mind you, it's not done. I need to align it yet. I need to do a calibration. I'll do it later on. I'll sit down and go through a process. There's not many adjustments in here. I think there's about 5 adjustments, something like that. It's not many, so it won't take long to do it. It's just a matter of sitting down and having the patience to do it. Clean the flux. I did clean the flux. You also missed that bit. Right, I think I'll put this to one side as it is, and I'll do the alignment later on. Right, what should we do next? I have this thing. My bag next? Nah, I've got some mail, but it's not prepared. So I'm not really ready to do a mailbag. It needs to be organised a bit first. So I've been asked to look at this thing. Apparently it's dead. I haven't looked at it yet at all. I don't know. Should we do this? do a resistor hunt. No, I found it now. It's all right. It's all good. The okay, let's do a video on this. I'll get the lighting on it so you can see what it is. I don't know. Batteries left inside. Most likely. Right, let's look at this radio here. This is a Sony airband radio. I've been asked to look at this thing. Apparently it doesn't work. Apparently it was someone's father's, like their father's dead or something, and they want to get it working again or have it for posterity, I'm guessing. Interesting knobs on these. When they're popping out. Curious. Wonder why to do that. Anyway. Yeah, so I don't know. I think they want it working because, you know, why not? But I haven't looked at this at all yet. I don't know what the story is with it. Yes. Anyway, let's dig in. Let's look at the basics first. There's a battery pack there. TC panel can go, but the problem is when I quit temperature controller, there's an issue with it actually stays on the screen. It doesn't actually get rid of it. So I have to manually turn it off. Let's turn the soldering on off for now. Give us some of the noise. Well, let's start with the battery pack, because this is the most likely thing to be wrong. And yet there are batteries in it. Let's have a look inside, see what they actually look like. If they're dead or not. This is an interesting pack. How does this go together? There's batteries in the bottom, but I can't see how to get them out. How does that work? Oh, there we go. Slides out. Here's my cat. The last surviving cat. Come on, George. Do you want to have a look? Do you want to do a cat scan? No? What do you mean it's knackered? Come on. Old girl. It's 20 years old. Last one. Right, so. Battery pack. Bit of corrosion in there. Just a little bit. Looks like it's been cleaned up already though. It's not looking too bad there. That looks alright. And that end looks kind of okay. So it's just a little bit just on this one here. So I don't think that's going to be a problem. I might just chuck a bit of vinegar on it anyway. Just to be sure, but I think it's probably fine. Here's some vinegar. George, you're in the way now. Come on, head away. I don't know why I'm talking to her, she can't hear me. Deaf as a post. Alright, let's just spray a bit of vinegar on this because there is a little bit of corrosion, just on one bit. Yeah, that's bubbling away. So there's definitely something going on there. It's not much, it's just a tiny little bit. Almost insignificant. But you never quite know. We'll all the simple things out first. When it comes to battery powered devices, it's often the battery which is the problem. Yeah, Georgia's old now. She's say 20, and both her sisters died the past year. I mean, the other one died what, 2 months ago now. Paul, which was the one which I've shown on videos before, the white and ginger one. She was my favourite cat. She was awesome. That cat. She was really, really good. Miss that cat. She's good. And then then Pippi, the black and white one, died last year. So George is the last one. At one point I had 7 cats, and she's the last one standing. And she's actually the one I thought she would die first. Because she's always had skin issues and stuff like that. She's, being a ginger cat, she tends to get skin issues. And although strangely, that kind of settled down the past couple of years. But she's had skin issues all of her life, where she'd be itchy and scratching and over grooming, that sort of stuff. And since she got put on steroids, all that went away. And she's just now an old manky cat because she doesn't groom herself. Whereas before she used to. Anyway. So the actual terminals here, they're looking a little bit dodgy as well actually. I might just put a little vinegar on this from here. It's a Talkman. No, it's not quite. It's a radio. Anyway. Yeah. Flash it a bit of IPA. Right, let's check the batteries out. Right, let that clean up a little bit with that vinegar and flushed it with IPA. Let's check the actual batteries, see what they look like. And that's good. 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 And good. So that pack should work when we put the batteries in. Just to rule that out as a problem. Let's check the terminals, make sure we've got a voltage on the end. 6.2 volts, yep, that's fine. So let's actually see if maybe it's the way they put the pack in. Now let's look at the other side of it, let's look at the radio. The radio's got these terminals in there, which aren't too bad, but looks like there's a little bit of corrosion on those as well, or a bit of dirt. We shall give those a clean up as well, and just to be sure, then we'll try it again. So I'm actually going to get a swab for this. Let's try IPA. I don't think there's any real corrosion, I think it's maybe just dirt, so let's try a bit of IPA on it. We'll see how that goes. Maybe do some corrosion here. Because the IPA is cleaning it up. There's It's not really much coming off. The middle one here, which I'm guessing is for a rechargeable battery, which just doesn't have fitted. There's nothing on the middle terminal. We'll clean it anyway. But this one here, which is the one which had the most corrosion, I think. I guess it goes that way in, doesn't it? Yeah. So there's one which was dirtiest, is the one which has got dirty mark on this pin as well. So, yep, just there's pretty dirty. So I might need to use some vinegar on that as well. Max Life's good cells, are they? Don't know, I never really tried them, I think. Let's put a little bit of vinegar on the other end of this. What I actually think's happened is gone through the nickel coating. I think now I can see the copper. Just making sure I did actually get vinegar on it. I wasn't sure. Right. Well, let's just try dropping it back in like that, because it also goes that way around without the holder. And how do you use this damn thing? Power button. Oh, that powered up. So it's doing something. Was that the problem? Don't know. Let's put the pack back out again. We'll put it back in the holder. I should record video. I keep forgetting to do video. Record video, Scott. I'm over YouTube. I need to record video. Keep forgetting that bit. So I'll put the back in again. We'll power it up, and we have power. Now, question is, does it work? No sound knock on here. There's no scratch. That's on FM. So I would be expecting to hear something. AM? Nothing. So is that the fault? There's no sound. Possibly. I've got no idea how to use this thing, but we'll figure it out. I have an RF signal generator. Let's power it up. No static at all. Yeah, I expect to hear something from it. Just about locks on. Just about. Let's do 76 megahertz. Let's do. No, it's too much. Let's do minus 73 dBm. That should be good enough. Well, FM modulation. And we would do 10 kilohertz modulation. So we're outputting a signal now. Okay. So I've got my signal generator hooked up to this thing. I'm injecting at 76 megahertz a minus 73 dBm signal, which should be strong enough for it to pick up, and with 10 kHz modulation. There's nothing there. Absolutely no sound whatsoever. So it's also got like a receive indicator, I'm guessing, but there's nothing lining up. So is it actually dead? Is there no receiver? The fact I'm not hearing anything at all, I mean, it could be no audio, could be an audio issue, right? Things like headphone jacks are a common failure because the little contacts get weakened and they stay open. Especially if you've had a headphone plugged in a lot, they'll tend to stay open and they won't actually close and re-enable an internal speaker. We can verify that by plugging a headphone in or earphone. But it looks like there should be a receive indicator looking at this, but there's nothing showing up. So, don't know. Scan. Well, that made a sound. Oh, I heard something then. Just very briefly, I heard something. Right, so there is something going on here. The speaker is working. I can hear it ticking as it's scrolling through. So I've got a 76 megahertz signal, so I should stop at 76 megahertz when it gets there, because there is a signal there. That beepers when it gets around to the end of frequencies. Carrier frequency 100 megahertz. No, I went straight past it. So it's not receiving anything. Receiver is dead. That could be problematic then, couldn't it? Which means I probably need to pull this thing apart. This is looking a bit more involved than I want it to be. Buffering. I don't know. Let's have a look. I'm not dropping any frames, that's a YouTube thing. Right, let's open this thing up and have a look inside. See how hard it is to have a look. But there is sound, but there's just no reception. Which is probably a power supply problem, probably bad capacitors. But the problem is something like this is not easy to work on. Really not easy to work on. Take these ones off as well. Okay, you're in. What can we see? Well, this is old technology, isn't it? This is 80s kind of construction for these kinds of devices. maybe even into the 90s, I'm not sure. So there's a mess around there. Is that just glue? Guessing it's just some kind of glue. Probably put it onto those trimmers to keep them stabilised, don't move. Yeah, well, this is the receiver board. The antenna goes into this board. So this is all the filtering, IFs, that sort of stuff. It's all going to be in here. There's an AF connection just there. Some of these things are labelled, which is nice. Various trimmers. But it's likely to be bad capacitors. Now obviously you've got the control board underneath it sandwiched down there. I'm not quite sure how hard it is to separate all these things, because these are usually pretty crammed in there. So hopefully no one's been in playing with adjustments, because that'd be a bit of a nightmare. But I'm just going to do a little visual thing right now. Let's look around, see if I can see anything which looks bad, which may not be easy to tell anyway. Yeah. Well, injecting into 455 is one thing. First thing I'll do is find it. Well, I mean, this would have multiple tuning circuits depending on which section it's using. Obviously, there's multiple paths. There's a path here. There's a path here. You got mixers and stuff down here, most likely. These would be IF around here. There's an AF marking here, so I'm guessing that's audio output. So it probably travels around like this. There's a 3-volt marking here. SD, clock. So some things are marked, which is nice. But it's definitely surprising that it's completely dead. I mean, I could try different bands in case it's just one band only. You know, I could try an AM or something like that and see if anything comes out of the AM mode, because there will be different paths for each one. Because you've got 144 to 174 here. You've got airband here, which are different filters, so these are the two different paths. And there may be more. Yeah, but visually I'm not really seeing anything obvious. Apart from that glue residue around there, which looks a lot like glue residue. I'm sure it's glue. Yes, it's glue. Now, on one edge, one thing which could be, as if this glue is like other glues, it can actually corrode away the wiring. I'm just looking to see if it looks like it's corrosive. It doesn't look like it. I can see a component leg underneath it. It looks like it's fine. So some glues which are used in older gear, a bit like the glues actually here. You've got this brown glue. I don't know whether you can see it on shot now, but yeah, I'll try and show you it. You've got this brown glue like this. This glue ends up being corrosive after a while. It also starts to conduct. It becomes conductive and corrosive. So if there's much of this stuff laying around, it could be a problem. But it's always this one. But this one's actually looking kind of okay. It's still quite soft. So I expect that the rest of it's all fine. You know, the fact that this is still soft and the light brown means it's probably alright still. But what I'm looking at is the glue over here, which isn't the same glue, but I just want to check it anyway. Let's see if we get any conduction here. Even the probe's really close. No, it's not conducting. Let's check the brown glue. So because it still looks really good, I don't think it's going to be conducting. It's looking fine right now. Yeah, the brown glue is not conducting yet, which is a good sign. Means it's actually in really reasonably good shape. Well, no receive. Why would there be no receive? Can't see any signs of leaking capacitors. Well, that's looking alright. We've got a couple of tantalums in there. Suppose we could check those. It's a receiver only. It's just a receiver. I need a snack. I've got myself a snack bar here, ready to go. Well, I can find a manual for this thing online. That might be useful. Find a circuit diagram. Air 7. Sony Air 7, 751. Being of that era, there might be a manual for it available. I think I found one. Can I wait for it to download? .45 megabytes, looks promising. Well, it's the right unit. Now, oh, there's a ball out. Nice. Well, it's definitely looking promising then. Anyway, circuit diagram is what I need to start with. Here we are. Let's we'll hide this bloody menu on the side. That one. Let's see. Where's the antenna? There's the control board. antennas here. So you've got some very cap tuning diodes here to adjust the tuning of the front end, and here. These are some input protection, prevent overloads. So we've got the first amp there. There's a mixer and amp. Here we start to split off. We've got some filters. This we're starting to get into IFs. Just want to understand this circuit before I go dive into it too much. And there's the AM side, is a separate board. That's the AM path. So that's the FM path, this is the AM path. Okay. So got a DC-DC converter down here. Could be bad capacitors. So right here should have 23 volts. Right there. If we can find that and verify that one for a start, check voltages. The 3-volt rail there. Also you've got digital side. I mean, digital side's working. But it could well be supplies which are relevant only for the RF section. Audio is half working. We know that because it beat. So there is tones coming out from that. That'll be coming from the processor, which will be coming from there. Right, so the IC, this one here. Is that going to be it? Yeah, beep. There we go, beep. So that comes up. That's the audio input here to the amplifier. So from this part there is working, which rules out a 6-volt rail and a 3-volt rail, potentially. But before this point, the volume, this is the volume control, and that's the RF input or the IF input to the volume. So this bit here, backwards, isn't working. So what I would want to look for is what voltages we have. Does that DC to DC converter come in here? Well, these voltages are actually quite low, only a few volts. Yeah. But it could be bad capacitors. I mean, you've got a series capacitor right here, for example. There's one there, there's one there, there's one there. So if it's bad capacitors, it could easily kill the audio because it's going to be a pass-through. Right. There's a lot of digging to do on this thing. I'm not sure if I want to spend this money because this isn't something of mine. This is something I've been asked to look at. And I don't know, do I want to spend a couple of days working on this thing? Potentially. We'll see. So we've got two paths we could look at, right? So we've got that FM path and we've got the AM path. If I can inject an AM signal as well, because that will go through this secondary path here, different IF, different filtering, and it taps in here. Right, so AM goes through this stuff, then it taps into this point here. So that's common. So I would know if it's before or after this point if I could check the AM side as well. If the AM also doesn't work, then it's likely between these 2 points, between here and here, which is bad, which narrows it down quite a bit. But we've got voltages here which I need to find. If I can find these voltages, those test points, then that's likely to be a good way to go, is check voltages first. Because it could just be a bad capacitor shorting out a supply rail and it will kill the whole thing. Or it could just be audio can't pass through a capacitor. Because that's something else I've also seen doing radio stuff. Capacitor goes open and you can't pass audio through it. Right. Well, my site still does have good schematics, but it's all in the members area. The public area's got low resolution ones. In most cases, there are some which aren't low resolution because they weren't very good to start with. But yeah, the public area's got low res ones, and the members area's got the high res stuff. But I haven't really done much in the way to update it in a long time. It's still got a lot of information there, and I've got gigabytes of information to put on there, but I just haven't got around to doing it. I don't have any of the latest radios, stuff like that on there. Yes, what to do? Do I want to invest too much time on this thing or not? I'm not really motivated because it's not mine. It's the problem. You know. Yes, but then it could be an easy fix. I might need to study this a little bit and just get my head around it all. POLs are often a problem. There's several things it could be because of the age of it, you know. Because it's so old, I'm definitely leaning towards bad capacitors, but there's a lot of capacitors in this thing. So it's like, which area would you focus on? There could be multiple faults, and quite likely is multiple faults. I'm looking at POLs and VCOs now because I'm thinking if I go to that first, because that might tell me if a POL's running. Because just because it's got a scanning function doesn't mean that the POL is actually following that scan. Does this thing look at what the POL is doing? I don't think it is looking at it. It's only outputting data in. Yeah, it's a serial control POL as expected. So this probably isn't actually looking at what the POL is actually doing. It just assumes it works. So it could be the POL is not even working because the crystal's not oscillating, or there's a supply missing, or the VCO's got an issue with the capacitor. This is VCO here. Tuning capacitors. Power supply here. So this, what's that rail there? There's already parallel with this line. That's a tuning control because all those reactor diodes are in parallel with each other. So that's a tuning control, this one here, from this point. And here. Comes back to the DC. I can't say it. Comes back to the DC to DC converter again. Obviously, it's controlled from this circuitry, which comes from this, which comes from the phase detector. So the higher the voltages from the phase detector, or vice versa, it changes the tuning. Right. Nice one. So I think I need to check for this first to see what we got coming out from here. Now the thing is, these voltages are specified may be under certain conditions. So if I don't find a voltage there, it may not necessarily mean it's got a problem. So if I can find this point here, C281, 282, D213, it's probably the best bet is 213 because that's probably got exposed leads. And I can measure at this point around here somewhere. 0.6 volt that side, that's a Zener. There's a 6 volt supply here. 6 volts, 5.4 volts. Ripple filter going through this way. Band selection supply. Yeah, I think I need to start here. This seems quite common to a lot of stuff. There's 6 volts coming in, so if the 6 volts missing, or there's a problem with the 6 volt rail, we just see that. And then if that 23 volts is missing, that will affect all the tuning circuitry. So it could be it's deaf because it's out of tune, because it's not tuning. I think I need to check this. So I need to find these R283, 281, 283, 282, 281, 282, 283. Got to find those. Got to find those, which are here somewhere. This is the top board. These are all single digit numbers. Is that on a sub board? I think it's on the other board at the bottom. These are all 100s. 100s. Damn it. I think I'm on the lower boards. Yeah. 285, 284, 283, 281, 282. There's the parts we want. And they're not on the top board. They're on the POL board. We're just sandwiched in there. Yay. This is going to be a pain in the ass. Let's see how hard it is to get it apart. Your ball was inside here somewhere. I'm not confident. Interesting, it looks like a screw missing from here. Is that it? Sure there's more. Yep, there it is, down there. Yeah, this is what I was worried about, being hard to bloody pull apart. I think I have to lift the whole thing out. Because I can't really test the voltages if it's in bits. Not easily anyway. Yeah, none of this wants to lift off. This is going to be a nightmare to work on. Where the hell is it? It's in there somewhere. That sandwich right in the middle. Oh, man. So I'm trying to get to the POL board because that seems to be where there's a DC switching supply which I want to test. But trying to get to it is a nightmare. It's sandwiched in the middle of all this stuff somewhere. Yeah. This isn't looking like much fun, I have to say. I was hoping I could lift that board off, but that's not going to work. So I lifted the whole thing out. It's just two screws, lifted the whole chassis out. There's a screw here, there's a screw there, which go through the casing. And that's going to come out easy enough, but yeah. Problem with working on this kind of stuff is that it's always really compact. So looking for that DC converter, that's like, I think it's probably the best starting point because there's several things I can measure there. I don't think it's actually going to solve the problem for testing it because it's going to create more problems trying to get to it. I'm not liking the chances of this. Capacitor, there's some more glue on it. Glue's still soft, so it's alright. But this era, these are Rubicons, and if Rubicons from this era, they are often bad. This age Rubicon is usually problematic. Yeah, I've seen them many times in CBs where they're just dead. Completely dead. This is going to be a nightmare. I'm not keen. Do I continue with it or not? Well, I mean, for video content I suppose it's worthwhile, but I mean, I could spend days on this thing. Seriously, I could spend days on it. Let's just check this capacitor here. Can't even see it. Barely. Struggled. 330 microfarad, 0.4 ohms. Well, yeah, they actually tested okay. I'm surprised. That might be alright then. That's my experience of that era of Rubicon has not been good. 4.8 ohms, that size is probably fine. There's some tantalums here. Let's just quickly see if I can poke into these. Doubt I was going to get much out of them. No, I can't really get to them. Poked right into the ball. I don't know. I'm actually hesitant to go any further with it, to be honest. I know the answer. Yeah, I know the answer is to spend a ridiculous amount of time working on it. If this was mine, if I owned this, and it's something I'd use, then I'd absolutely sit down and spend a week on it. Right, this is, if it's mine, I'd definitely take that time. But this is someone else's equipment, and to be honest, it's not worth the money for them to pay me for that time. I'm trying to think about, you know, what it's worth to them. For them, it's inheritance items, so it's got some value to them, emotional value and stuff like that for them. They'd like to get it going because of that, and because of that, I would also like to get it going, but I don't know. I'm just not liking my chances. I mean, I've had this kind of equipment before, and it's just been a nightmare. It's been a rabbit hole of trying to figure out what the hell's going on with it. And the board I want to test is buried inside it. I think I just don't think it's a good idea. I mean, for it to have died, it likely is just a capacitor problem. But which one? There's loads of them. And to test them all, we'll get it apart. Let's see if I can get any further apart. There's a screw here. We'll just delve slightly further into it. But I want to be careful not to overcommit. The fact these screws are really tight means no one's ever been in here, which is a good thing. Alright, that's sandwich coming apart. Right, so there's the board I actually want to test. Maybe I can test it to power. Maybe I can. I might have a close look around inside here and see what I can see. It's got LEDs in here. There's two LEDs sitting right there. I mean, I could do like traditional troubleshooting I could do on CBs and other radios, and the principles are the same. So at the moment I'm kind of debating how far I go with this thing and how easy it is going to be to fix. I mean, it's a sandwiched apart, but the sandwich came apart there. That's not too bad. It's quite good. Interesting, there's a couple of LEDs down here, which are normally not visible. So those might be diagnostic LEDs. But there's lots of capacitors in it, loads and loads of capacitors, and they're all small capacitors, right? And the problem is, generally, the smaller capacitor, the more likely to fail. I'm going to have a close look. I mean, I can see stuff around there that might just be glue, might be more glue, because it's by inductor. Yeah, it's more that glue, and it's on those capacitor legs as well. But it's the other stuff which looks dark, so I think it's fine. Yeah, it seems that all the coils have got that on them. It helps probably stick them to the board so they don't get dislodged with the weight if they get knocked. Yeah, this and that glue up there, the brown stuff. Still soft. And there's some down there as well, but it looks fine as well. It's not gone dark yet. Usually when it goes dark, that's when it's going to be a problem. So I think I'll try powering this up again because we've got these two LEDs down here. They might tell us something. But I'm not confident about this thing. I can get to some more capacitors on this thing. I can get to a few component legs. Maybe I can test some more caps without dismantling stuff too much. Maybe I'll stumble across one, but I'm not at all confident about this at all. Just this kind of radio is just not nice to work on. Let's try some caps first. Let's do the easy stuff. .7 ohm, that's alright for that size. 3 ohms, yeah, probably alright. There's some more of that glue just down here by these capacitors. Right there, some glue. This is a bit harder, actually, this one's a bit more rigid. Let's see if I can get some small capacitor legs. .3 ohms, that looks alright. Well, you know, I'm not seeing any capacitors which are obviously really bad because that'd be easy, but it actually makes the situation worse. 0.68. Yeah, I'm really not confident about this. Anyway, let's power this up, see if these LEDs do anything. What could possibly go wrong with all these bits of metal casing floating around? Right. Yes, power. LEDs, got nothing going on. Which was the scan button. That's one of the scan buttons. LEDs, nothing. Nothing going on those LEDs. Now, what to do? What to do? It's more complicated than I want it to be. I mean, absolutely, yes, I can sit down and fix this thing. I'm like 90% sure if I sat down and worked through it logically, I could fix it, given enough time and motivation. the time motivation of the problem. I mean, we know we have audio, so now the audio amplifier and the speaker's working, we know it's not that. It's definitely an RF problem, but why is there an RF problem? Is it a tuning problem? Even the speaker's falling out now. It's getting smaller and smaller. Right. Can I set this up to work on it like this? Maybe. I don't have to get to digital board, that should be fine. It has to be this board or this board. Be careful not to snap wires off, if it's any problem. That would be a bit inconvenient. Yeah, we have to kind of leave it like that. Right. So in the background, you can probably hear my NAS running. It's syncing files. Can't do anything about that. Alright, let's look at this board again. Let's see if I can figure out something. I'm not quite ready to give up yet, but I'm close. So those things we were looking for before, let's go back to here, is in this area. So which area is that? Ribbon cable? Where's the ribbon cable? I'm trying to even identify where that bit is. Ribbon cable's over here. So this board is upside down compared to that view. D212, I can see that. I think the resistor's on the back of the board. Because the back of the board is absolutely stuffed. The board has to come out to work on it. This isn't helping my motivation. Yeah, I'm not convinced that I should carry on with this thing. It's just too bloody hard to work on. Please inject something, you're saying. Who's the squelch control? Yes, I made sure the squelch was open. I did check that. Well, I did check that squelch was set to be open. Yeah, I'm just not motivated. I'm not feeling it. Ugh. Let's look at the IF stuff. Let's have a look there. Right. I just realised I forgot to change camera view so you couldn't see what the hell I was talking about. Other stuff's in here. Is there anything in here which is going to be useful to help me diagnose it? I haven't actually looked very far yet, have I? Usage information. Block diagrams. Look at the block diagram, shall we? Sometimes that's useful. Okay, so actually this is POL. See, I was talking about POL before. The microprocessor is looking at the POL. It has got log detection, so the POL itself is probably running. Right. So I'm thinking it's an RF issue. Could be power supply. Could be the AGC is knackered and it's shutting the RF signal down. Got AGC detection, right? Or my gain control. So what you normally do is you get feedback from here, like you can see it here, actually, convenient. Feeds back through diodes and those actually shunt down things and amplifier there as well. So there's a signal here, which is basically an IF level. And when the level gets high enough to trigger the amplifier turns on and it will actually shunt diodes across the supply, across the IF lines to protect the front end. It's not displayed very well here though. But there's a capacitor right there. Sometimes they pull down, systems not pull up. I've seen that before, where it was actually shorted the ground and it was killing it. So AGC is going to IF amp and the IF amp here. And that mixer there, so it's not doing it right at the front end, it's actually doing it further down the RF strip, which is quite interesting. Normally I don't write the input. Anyway, there's a muting drive, could be muted. Then there's no RF signal. It could be muted, but with an RF signal. Muting is probably the squelch system. Got FM detector here, D21, D22. There's the AM path here, so D32 is the joined path, and D33. So yeah, right before volume, that's the joined path that all come together. Okay, thanks for dropping by, Sven. Catch you later. Have a good sleep. Yeah, I don't know. I'm on the fence about this. So you've got 455 megahertz filter here, 10.7s here, 55 megahertz for these. So the local oscillator's there. Yeah. See, I'd be inclined to test before the detectors. So that's 10.7 megahertz here, right? So this mixer here is dropping down to 10.7 megahertz. So if I were to inject 10.7 megahertz here, at this point, you should tell us whether it's this half of the circuit or this half of the circuit. CF62 and wherever the hell this bit is. That's the amplifier, that's the amplifier. AGC's coming in there. Yeah. Let's look for CF62 on a circuit diagram. Oh look, the Sydney instructions, how to get it apart. That's helpful. This should adjust it as well, it's all in there, it's good. IF adjustment. That's no good to us because it relies on having audio, we've not got that. FMIF is based on audio output as well. So is that. Main injection probe, empty ballpoint pen, capacitor and a sine needle wire. Well, VCAs must be working hours of PO and lots, so I can ignore that bit. I was trying to see anything in here which would allow me to shortcut the process a bit. Not really. The layouts again, and more diagrams. Seem to have lots of them. Interestingly. And more layouts, and more diagrams. Why are there multiple layouts, multiple diagrams? It's weird. Right, IF stuff, it's up here somewhere. CF61, CF62, R44. Well, I want to find something I can access from the top side because these will be on the top side, but obviously connections will be on the bottom. Resistors on the bottom of the board because it's double-sided and it's service mount. Where is this stuff? Yeah, I'm not really feeling this. IC1. Maybe I'll get to one of those IC leaks. Let's have a look. There's IC1. That's on the other board. It's on this board. IC1 is down that side. That's one of those heat-sinked devices. Maybe I can get to these ones. That's there. pin 1 at the top. Okay. So it's got 2 amplifiers. Interesting. So you want pin 1 of IC1. I can get to that. Hopefully. Hopefully I can get to that. Yeah. There's a filter. And there's the other filter. So hopefully I can get to one of these parts. Let's have a look. This doesn't look the same. That's not the same board. It's very similar. It's not the same layout. It's not the same board. Maybe it's one of the other layouts. Let's try the other ones. No, that's the same. This layout's not the same. It's not the same bloody version, is it? The chip's in the same place, but the circuitry around is different. Yeah, that's the same as the others as well. I don't have a filter here. Well, the chips are the same layout, so maybe it's a minor revision. Let's see what I can do. Let's see pins. But can I get to pins? The pin I want to get to is obscured. Well, that sucks. I'm actually looking at how long these component legs are and how close they are to the metal frame. I do have an insulation layer on there, but that's not going to protect it forever. That might be right. Unfortunately, I can't get to the lid I need to test. And as the board layout's different, I can't just find another place easily. And there's the filters, but I can't actually hook into them. There's a 455 filter there. I can get to some resistors, but the layout's different, so I don't actually know if it's got the right one or not. There's a filter 81 up here. There's an AGC link here. Yeah, these also a different way around. There's AGC 1 there, there's AGC 2 here. Ah, hold on a minute. Maybe it's not so bad after all. Hold on. IC1, IC2 I mean. Let me look at this again. Am I looking at this wrong? I might be. That view is this board, upside down, bottom view. So I'm looking at it this way. I actually think it's that way. So that's IC1 there, pin 1's at the top, which I can see. Right, okay. These layouts are doing my head in. All from the bottom side of the view. Bottom of the board, not top of the board. Every single one of them. You think some would be top. Such good documentation, it's worth the effort. Well, yeah. Let's get a scope probe. Let's try probing it with a scope first, see if we see anything there. I'm injecting a signal. I prefer to test for a signal rather than inject one, if possible. Injection is always a possibility though. If we roll it out. Right, so I'm going to plug this back in. Now with that like that, should I put those screws back in again? I think I probably should. Stick one of those screws back in again, hold it together. No work. It doesn't pop off like that. So I'm injecting that, I guess, through 76 megahertz again. I've got 10 kilohertz modification, 10 kilohertz modulation still. Let's turn this on. 76 volume control was scratchy. Squelch is definitely down. Let's see if we can see anything here coming through. I'm not going to show you the scope right now, I'm just going to play with it myself to see what we're getting. I'm getting a flat line. I need to change my scope setup. One mega and 10 times full bandwidth. Yeah. I'm getting 1.4 volts, which is what's on the circuit diagram of a flat line DC. No apparent audio. Purely a voltage. Changing modes doesn't change it. Let's go to let's do AC coupling so I can zoom in. Nothing. That's completely dead at that point. So I'm just probing the input of IC1, which is an IF input here with my scope, and I'm getting 1.4 volts as specified in the manual for it, but I'm getting no audio or any kind of signs of life. Changing modes, you expect to see a difference happening somewhere, and I'm seeing nothing happening. I'm not seeing any kind of waveform which would indicate life, so it seems at that point it's dead already. Oh dear. So right there, I'm getting 1.4 volts DC correctly, but nothing else in any mode. Yeah, it would be IF frequency, yes, but I'm not seeing anything there. I'm not seeing 10 megahertz there. All I'm seeing is a slightly noisy DC. I'm seeing nothing else. I'm getting 1.4 volts. That's there at least. But that is it. So changing different modes didn't result in any change in signal. It just stayed the same. So if there was anything coming through this path, I would have seen a change. So I think there's a problem before that point, which is killing it. It's not coming through from here. Again, it could be that tuning problem. It could be this bloody DC-DC converter is not running properly and it's not tuning the circuitry. So yeah, like I say, injecting a signal here might be an idea. Let's try shoving 10.7 megahertz in there and see what comes up, if anything. I should use a scope probe for it. I like using scope probes for injection because they're nice and precise. Carrier frequency 10.7 megahertz. IF level. Probably need to do more than that, eh? Let's do minus 10 dBm. I've still got modulation, 10 kHz modulation on there. Well, I'm going to try injecting a signal, which should be an RF signal, into this point, and we'll see if anything happens. Yeah, we'll see. Right. Nothing there. Nothing at all. No sound. Scorch is definitely down. Nothing present. So let's look at the rest of the IF path and see if I can inject it a bit later on, see if I make it come up that way. IC2 pin 7, which is the other one I couldn't get to. Let's try pin 1 of IC2 because that's further down the path. Still nothing present. Nothing at all. Looks like it's completely dead. Should be getting something somewhere. Dunno. So I injected here, and I injected here. Or was it there? There. Oh, I don't know, one of them. I injected one of these points. I definitely injected here. And this is 10.7 megahertz filters here. So another point said it was 10.7 megahertz. So it should be 10.7 megahertz here through the system. One of the other diagrams showed that frequency on there. Not this particular one. Which diagram showed that? Or was it the block diagram that showed that? Yeah, block diagram showed it. So 10.7 megahertz IF coming through those filters. So this point here, just got injected, will be 10.7 megahertz. So I didn't measure anything there, but then that's not necessarily unusual. On the air mode, it should go into 455. So it's got a different setup on either one, depending on which one it's using. Air's going through that detector. FM's going through that one. IFMs obviously don't care about that frequency then. So the other thing is you've got this receiver LED, right? Receiver LED, which was not lighting up. Okay, so this part here isn't seeing a signal. So if I bring this back here, we've got a 10.7 megahertz filter here, taps off this point. Well, it also comes through from these ones as well. Not quite sure which path it's going to be using. It's the air one. So that's the pathway back from this point. IF amp from the air band, which taps off here. Different versions for different ones. Okay. So there's no signal here coming through from this point to turn that LED on to say it's receiving a signal. So the radio itself is saying it's not receiving anything at this point. Well, the thing is, the audio amp is definitely working because it beeps. The CPU sends a tone through and it beeps. And I have heard scratchiness on the volume control. So adjusting the volume is working. I can hear it scratching sometimes. And this one here is the beep control from the POL. Well, it's the call it POL control, but it's the processor. And that is inputting directly in that path. So this point is working. The fact that this LED is not lighting up means this isn't receiving a signal. What's this manual auto thing, I wonder? Squelch manual, squelch auto. Where the hell's that? That's showing this. I haven't noticed it on it. And I've got the squelch turned down manually, but if it's got auto squelch, it could be overriding it. This is when the buttons fall out the front panel. I haven't seen a control for manual auto squelch. Where the hell is that? So even injecting the signal manually into the IEF and checking for the receive LED is not lining up either. That's 455 kilohertz filter there, and 10.7 from here. Can't find this. There is a switch, but it's not for this. It's for step sizes, AM step sizes of 9 kilohertz, 10 kilohertz, or something like that. Anyway, it's inside the battery compartment. Don't know what this is. Where is that? Is it in its position on squelch control? Did I miss this position? No. Because it does like push in. Let me just try it again without that. Oh, for God's sake. Okay, right, progress. Progress. Oh, now just push the button. Right. So the squelch control. Can you see that light flickering there? As I push that in and out. And now I can actually hear a bit of noise in there sometimes. So it looks like that is actually a switch for auto and manual squelch. Now let's inject a signal. This is a 10.7 kilohertz signal into pin 1. See the light come on? So there is something there. This volume control is knackered. There we go, there it is. It's bad switches. For fuck's sake. Dirty switches. Right, let's clean these bloody switches up. Yeah, you're right to push me to make me keep going. Good on you. Well done. Let's give these bloody switches a damn good clean. If I can. Oh, looks like they are open back there, so let's do that. Deox it. Give it the good stuff. Let's try not to get deoxit all over the circuit boards because RF circuits don't like dirt on them. Try and juggle this in a way so I can get in there without it going everywhere. What a bloody annoyance that was, eh? I'm sure it's going to get in there that way, but we'll try it. It's never the cap, it's always the switches. Oh. I don't know. So I think the switch for the squelch was messing it up. And the volume control being a bit dirty is also messing it up. See if it will still work when I actually inject a signal rather than just an IF signal. Alright, let's put the battery back in. Still really scratchy. This control's still aren't good. The deoxit's not got in there, I think. Let's try to inject any signal again. Now, still more going on than this. This volume control is not working nicely. No, still something else going on. It's not just that. like when I do the manual squelch open, or whatever the hell I'm doing with this switch, then it comes on, it stays on. I'll try and zoom out a bit, maybe you can see a bit more what I'm doing. So I'm pushing the switch in and out. Once I do it, then it comes on. Right, so I'll take it off. Right, it's lost it now. I'll put it back on. It's there. Right, leave the switch out. Put it on there, it's not showing up, regardless of squelch position. But as soon as I push the switch in, it comes up. Now, there's still more going on here. Well, let's put some more deoxit in here, try and get deoxit in there, because I don't think it's actually got right in. I'm thinking there's probably, it probably is a capacitor problem. But then it was still getting crunchy with this volume control, so I don't know, I'm not completely sure yet. And the volume control comes back around to this side over here. It could still be bad caps. Yeah, I mean, the caps I've tested so far have been fine. But capacitors can cause this kind of problem where it's intermittent. So the capacitor basically goes open or shorts whilst you're doing the testing. So I've seen stuff like that happen before. So I'm not ready to rule the caps out yet. Let's put this back in here in case the earthing matters. So I did the squelch, then it actually came up instead of relying on pushing the button. Yeah. This does seem like bad pots and bad controls. Well, let's just try doing normal signal now. Now we know we've got that much. Let's try injecting 76 megahertz again. And we'll see if that actually does anything or not. Frequency 76 megahertz. And IF level. Yeah. Here we go. Yeah, that's working. Apart from the controls. It's the controls. Definitely controls. Now I've lost it again. Yep, lost it again now. And from scratching this to nothing. I mean, if someone put bloody oil in there. I know that some people use oil on controls. I know I did it many, many years ago. I put WD-40 in there because it worked, but not realising that it does tend to destroy them after a while. So I wonder if someone's done that, put oil in these, and it's messed them up. Don't know. Yeah. The thing is, trying to get some replacement pots for this would be just about impossible. I've never seen pots like this. So right now it's like, nah, no good. Oh, there we go. Something else that occurred to me as I put the D5 in there, not the fader D5, not the fader stuff. Anyway. So yeah, it does seem to be purely a control problem after all. They appear to be a bit knackered. Don't know. Right, so it's working there. Let's turn it off. Turn it back on again. Still working, okay. Right. I might see if I can do something about those pots. Maybe I can pull them apart. I doubt it though. So, it does appear to be these controls. I've got a problem with it's working right now, but it's really erratic. So this is injecting 76 megahertz from my signal generator, so that should be working correctly. But this is really glitchy. These pots appear to be bad. Right? Yeah. That's the problem. Well, I don't know. I'll let you know if I fix it. I think the pots might be beyond fixing. We'll see. Yeah, can I get them apart or not? Usually, I mean, sometimes you can, sometimes you can't. I'll certainly have a look, see what it looks like I can pull them apart. If I can pull them apart, that'd be worth doing. It's probably just the fingers that got a bit weak inside and it's not making contact properly anymore. Many of the plastic housings. I think these are just moulded ones. I'm not sure if these are actually doable, because you've got the front part there is probably an actual pot just there. So this is the switch mechanism part, because obviously this goes up and down. Right, so that's the switch in the back part. The very front part there would be the pot. And it looks like it's got pressed pins. I don't like my chances on this one. Well, it's the thing, whether it's meant to come apart again. Is this looks like it's got pressed pins. I don't think those will come apart. Well, they come apart, but I don't think I'll be able to get them back together again afterwards. Fortunately, that's not a screw. It's a pin. So that's what holds this onto the back of the pot. I mean, I've been doing it on this bit here. Maybe, I mean, I can see a bit of material here. It's like PCB material. We'll see a little dark brown bit. That's obviously going to be where the track is on the back of that. So, I mean, the oxide should have got in there. Should have done. Should I try running some down the shafts? Just in case it's not actually got right in there properly. I'll even use the right stuff this time. Yeah, I don't like to drill holes in shafts or well, in pots and things like that if I can avoid it. Don't like to drill holes in because you can get debris dropping in and then it can end up making the situation worse. I mean, it's okay as an absolute last resort when you can't do anything else. You've got nothing to lose, but I'm not there yet. Well, let's see if that's done now. Marginally better, has changed. Well, it has changed. It has got marginally better. Yeah, I don't know. I'm not convinced it's going to come right. Normally it would have come right ages ago. I'm just thinking this is probably beyond help. So the scorch thing's still not right either. Yeah, just normally I literally just takes a drop of it to get in there and it does the job. That's what it really needs. So this is really, I mean, it must have had some got in there by now, surely. You know, I'm pushing sideways, it's making a difference. There you are. I think this pot's knackered. I think it's had it. I'm getting a feeling that's not recoverable. Because, you know, it literally just takes a smear of that stuff to get into a pot and it will fix it. If it's, you know, it's a bit dirty, it'll just do it straight away. And it must have got in there by now. So, I'm pretty sure they have failed. Let's see if I can get this thing out. Oh, God. And they're really jammed on there, of course. They might end up snapping as I pull them out. There we go, there's one. This one doesn't want to come off. But to get the board out, I need to get that off. Leverage. The only problem is, I might end up ripping the bloody pot apart. Let's try and wiggle it a little bit. I think it's moving. Here we go, gotcha. Alright, let's take this out. Just in case it's bad joints on the board, you never know. Or if I can actually pull it apart to do it. I've had plenty of times on CBs where they've had like corrosion or water damage or whatever, and the pots are knackered and you have to replace them. And you try and pull the knobs off, or you need to get the front panel off to fix something like the switches or something like that. Maybe the signal meter is a common one. Signal meter gets ruined. And the knobs might still work fine actually. But you got to take the front panel off the radio and you got to take the knobs off. And by pulling the knobs off, you destroy the pots because the shaft will just rip straight out because there's actually not much holds those things in there. So, yeah. Anyway, we get these out. We'll see if we can do something with these. It does have some plugs. Come out all the way. Right, what we got on the back of this thing? Well, it looks okay. Really? Nothing bad there. Should record this, shouldn't I? So I pulled the adjustments out here, these pots. Single board looks fine. I can't see any signs of cat joints in it. There's nothing obviously bad there. So I don't think that's a problem. Unfortunately. I didn't think it was that, but the question is, can we get this apart? Is that a screw? Oh, that's a screw in the front. Look at that. We might be able to get it apart after all. Let's see what we can do. Which one was it? Which way did it go? Which one was the worst one? This one. This one here is the worst one. Let's pull this one apart. Oh, it's spinning, but whole thing's spinning. I want to get it apart because I think the finger's probably no good. I feel the whole shaft spinning. Thing is, it does feel like a screw. I mean, it's definitely got a screw head in it. And grab that shaft. That's what she said. That's what comes to mind, isn't it? I don't know. We can pinch it like this. Put some tension on it. Somehow. Not sure how yet. It's all a bit clumsy. No, it's just pushing it off. That's curious. It's almost like it is a screw, but it's not. What to do about this? I'll throw it on the floor, that'll fix it. I'll never see it again now. See, there's only one of them's got a switch on it. Only the squelcher's got a switch, right? The other side doesn't have a switch. A staked screw, yeah, I think so. Well, that switch part's working alright. Three hands indeed. Let's look at there, and there. You guys can't see it. Yeah, look at that, it's jumping everywhere. Now it's gone. There we go, it's got a little bit there. Lost it again. No, lost it again. Yeah. Did a bit just then. Let's go the other way. $19.5k apparently. Regardless. Oh, going to the wrong one, that's why. Go to that one there. So the carbon track is intact because that was okay. There you go. Yeah, so that's the problem with the wiper. Carbon track's intact, but the wiper's not touching it. And let's do the same check on the squelch side. If I can follow the wires around. Just go straight to the legs. Come on, get in the bloody thing. So with it out, it goes to that one there. Okay, so with it out, it's going through the pot from, that's the common. So I should be able to measure there to there as I'm turning it. So the first pot was volume, this one's squelch. And this one is looking like it's dead. There's nothing there. We go to the other side. Down there. Yeah, squelch is definitely bad as well. Same problem. Nothing coming through. We go across the pot. So across the pot? No, the other one's across the pot. That one there and that one there is across the pot. 35k. Yep, so the track is okay, wiper's not touching it. Both pots got the same problem. I don't think I've got any pots of that style. Let me have a look. I think he's going to be way too short. This is a switched one as well, it's got a switch built into it. But I think it's going to be way too short. And even with that pushed in, if I mounted it on there, those legs will line up. The switch I can bodge on, so it's got a turnable switch instead of a pushable switch. That could work, but I think it's too short. I don't know, I mean, they are in there. I mean, maybe I can make that work. What size are these? What value is it? So that's a 50k. What did I say that was before? 20, wasn't it? 20 and 35. $20k, 35k. $103, that's a 10k. So 50k or 10k. eBay had a pair for $20. Well, the thing is, like, for me, it's probably $20 for that, and probably $50 shipping. Because we've got these other old styles, but these won't fit. They're nowhere near fitting. They're just massive. It's a dual gang. It's not good for this. Yeah, so I've got those choices. Both are switchable. They both have switches on. mean, obviously you can ignore it for the on-off, well, for the volume one, but the I don't know. Could that work? Is it going to be long enough? And if I shove this in here like that, and shove that in the casing, is that going to stick out far enough? Which way did it go? It's upside down. Is it? Yes, it's upside down. It goes the other way up. Of course it goes the other way up. You just have to put it back together to put it back in. I don't know, so that is about in line with the edge of the B and C. I don't know, that might just work. That might just work. I might be able to go over it. It's damn close. Freight included, you reckon? So this is a 50. I don't know, I reckon I can get away with 10. I mean, a 50, is that going to work, you think? Let's have a 20. If I stick a 20k resistor across it, it might help. Maybe. Maybe. I'll bend these legs over. So I'm going to break them off. I'm going to try this and see if it works. So that's, I'm going to plug in the black one because that's the volume control. Well, maybe I might need both actually because it might not have a squelch otherwise. Let's plug them both in. Right, let's try and see what happens with this disaster waiting to short out. Around? Yeah. Right, so I'll just try putting in another pot. We'll see what happens with this when I turn the power on. If nothing's shorting out, I need to plug the coax back in again. Otherwise nothing's going to happen, because you won't have a signal. And my desk is getting a bit messy. It's asking for trouble. Right, don't short anything out. Hold everything. Power is on. Push the scroll chain because that's not working anyway. Oh, sounds like it works to me. Sweet. Even though the resistance is greatly bigger, because the original pot was a 20k, this is a 50k, and it works. So I can do the same thing on the squelch pot. If it physically fits, that's the other thing I've got to check, is actually put it in place, drop into the casing, and make sure that the pot actually sticks up far enough and actually put a knob onto it and actually be able to use it. Okay, and that's what I need to check next. Let's put a knob on this, just to, well, a bolt on this to hold it down. Should be the same size, often they are. Yep. Let's do that to hold it down. Drop that back into casing, and we'll see if it actually sticks out enough to put the knob on. If it does, then I'm going to do the same thing to the other one. If it doesn't, then I've got a problem. I'll have to try and find one which fits better. Okay. So that goes back into this. We'll slot together that. There's the casing, that's where the casing sits. Right, is this good enough? Push the knob right down. That's the wrong one, I want the other one. Look, it's just like... Not really. That's where that sits, and it's just like only barely anything there. That's pushed right down. That's not really enough to grab hold of. Next solution. Knobs. Can I change the knobs? Do I have something here I can use? This is quite a long standoff in this one, but it's somewhat ugly. I can find a knob which has got a long enough standing off on it, which will fit on these, which isn't too ugly. But you might be right. Maybe. But I need a pair. That's the next problem, is I need a pair of them. I'll come back once I've figured out if I've got one. So we've got a pair of those. These are ugly as hell though. And can I put two side by side? They're going to basically rub each other. I mean, this will work. They might, I don't know, they're really close touching each other. I can shorten this down a bit because that's not bottoming out right now. I can always shorten that shaft a bit, but that one fits in there. It's a possibility. Got this ugly one as well as this one. Nice metal one. How's that? Stereo knob. Got these, which nah, it's no good. Right. I've got this one, which is ugly as well. It's way too big. Yeah, I don't have any choices. Most of them are similar sort of size. Something slightly bigger. This one, let's try this. No, it's way too recessed. I mean, it'll work, but it's way too recessed. It's got a big massive gap around it. Gets on there really well though. So it looks like I do have a choice, but it's not a pretty choice. Yeah, well, I don't have many options here. I think basically the only option I've got is these ones. And then shorten that shaft down very slightly. And I may have to trim that outside edge. Just so I don't touch. But it's doable. But it'll fix it. I think it's the only choice I've got. Well, I found these ones which are a little bit ugly. They will just fit. They've got a big standoff on them. I might have to trim the shaft down very slightly to get it so it sits down nice enough. But I think these are doable. I think these will work. So I've got a choice of one. And I think that's what I'm going to have to use instead of using the original knobs. Swap them out to these ugly things. But at least then it will be fixed. That's the only solution I can come up with right now. The other annoying thing is these knobs, these are switched knobs. These are expensive to get. These switch knobs, these are expensive, these pots. I've got these for CB stuff. And I'm kind of loath to get rid of them. Because they're a bit unusual. But, that's what I've got. I don't think I've got any other ones. I don't think I have any others. Should I check my stash? Just in case I do have something else. I should do that. I also have this box of stuff here which is basically switches and stuff, so let's have a look in here. Just in case I've got something. Because I buy all sorts of stuff over the years. This is mostly switches, but there could well be pots in here too. Things like this. These little weird multi-turner things. Might have to move this somewhere else because I'm going to bring my packet somewhere. I've got trimmers in there. Digging, digging, digging. Come on. Hopefully I've got something. Well, I've got something, but it's the wrong kind of shaft. It's a D shaft, not a spline shaft. Keep looking. Ouch. I really hope I can get the stuff back in here afterwards. They're the same length. I think these are the same. Yeah. So despite all the stuff I bought, I still don't have the stuff I need. That's just typical, isn't it? Eh? Got all this stuff and I don't have the stuff I need. So I've got these. Ah, these are encoders. That's no good anyway. Variety of pots, yeah, I think that's where it's going to go, isn't it? I'm going to have to get a bunch of pots. So, no, I don't have an alternative. That's what I've got. So that's what we're going to have to do. So I've still got nothing to lose. I might as well try pulling this apart, eh? Just try again, try a bit harder. We can hold it with that. Maybe. This isn't looking promising. No. I'm sure that is like a bolt which has been pressed. Because it doesn't want to unscrew itself. I'll try and grab the shaft if I can. It's not working. I can actually see up inside the pot through that gap. See it there? Fortunately, it doesn't help me do anything about it. Well, I mean, I'm sure I've got a spray in here anyway. I think the sprung finger inside has given up. We can recheck it again in case we get lucky, but I really doubt it. I haven't got any bolts or anything I could put through here to hold it back together. It's just too small. I mean, this particular one doesn't need to switch anyway. Anyway. Let's have a look. Did we get anywhere doing that? I doubt it, but you never know. If I can get onto it with one hand whilst turning it with the other hand. Can one of you guys hold this for me? It'd be much easier. Nah, me going still. Nah, that did not work. So, it's definitely not a case of spray not getting in there. Well, I think I've only got a choice of just putting those ones in which I've got and changing the knobs and just doing that. I think that's all we can really do. I don't think we've got much choice. I think that is the only choice. Too messy here. Right. Well, I was getting it working, it'd probably be good enough. You know, I don't think they're going to care too much about the knobs being different. I mean, I don't like to do that, but at least it will be working. Which is, the alternative is I don't fix it. So, yeah. Okay. Let's get this other one out. This one's going to be harder to get out because of the switch. I need to desolder this one properly. I've already got one out, didn't I? Where did that go? I've lost it. There it is. Right there in front of me. So I can actually use a switch on this one and wire into these. It might be the same spacing on the back pins actually. No, it's not. It's different spacing. Of course it's different spacing. So how am I going to do that? And it's only a two-way switch. This is a three-way switch. Goes one way or the other. It's only got 3 connections. So when the switch is out, it connects the positive, well, the common to that point. When it's in, it goes through these resistors. So it doesn't actually need to be a two-way switch. Or does it? Or we do away with auto squelch and just have a normal squelch and forget the switching. What are these resistors? Another workaround I'm going to have to do. That's 23k, 45k. So that's putting 45k to that side and 25k to that side. Really? Something a bit weird about this. Those are wired across those are wired in series together across the pot. Right, so I've got these two fixed resistors here, which are in series together, right? So that side goes to that side of the pot, this one's going to that side of the pot, and then series together, right? So these are in parallel with the pot. So this could be a 50k pot anyway, because it's got these two resistors here. And when it's switching the common of those resistors or the common of the pot. So on these switches, when they're turned to the fully off position, it closes these contacts. I think it opens those contacts. I think they normally open. One of my lights is playing up. Something's going off up and down. Not sure which one it is. Yeah, so that's currently open. If I turn it on, then it closes those contacts. Yes. So with it on, you want scorch control, so that would be switching in the pot, switching in the center of the pot, or using the other two. So maybe if I wire the other two up constantly in place, then switch the pot on, would that limit the scorch range too much manually? Or does do away with auto scorch? Auto scorch isn't really auto scorch, is it? It's just a low scorch threshold on it. Well, let's get this out. I'll figure out what to do afterwards. This being a single-sided board means it's easy to get it out. In theory. Come on. Oh, I missed one. There's one leg soldered. That last one's soldered. Didn't notice that. I don't know why. Doesn't do anything. Must just be purely to hold it down. Alright, there's the other one out. So frustrating. If I can bend those forwards a bit, maybe I can get that in. Might just go if I'm really careful. Right, that just goes in there. If I can make any use of that, I don't know. Right. Even kind of line up. Now, what to do about this auto scotch? Decisions. So, the auto squelch on this is switching between a pair of fixed resistors and the pot. So the auto squelch isn't really an auto squelch, it's just a preset squelch level. Bit fake, really. So it's not so critical. It would be nice to be able to do some kind of auto squelch. I do have a switch, but it's only a single switch, it's not a double throw. It's only a single throw, and it's only thrown on when you turn it on. So I'm going to have to think about if there's a way I can actually wire this up to make this some kind of auto squelch system similar to what it's already got. Auto squelch. Or whether I just have to completely abandon the squelch idea and just have a manual squelch only, which is a valid thing to do too. Yeah, I need to decide about that one. What to do about that? How can I modify this thing? If I put a series resistor to the common, that won't really do anything. Let's measure this again now. I don't have that same circuitry set up. So there to there. I can get the bloody probe in there, stick it here. Come on. Yeah, 47k is that resistor. This one here is 37k, strangely. Maybe it's a 39. So it's like having a 50% squelch basically. So if I put a series resistor on the negative, well, the lower side, the downside here, like that's got there. If I made that resistor switched from that side, would that matter? Depends on how the circuitry is done. Yeah, I'll try and make things see what I'm talking about. So if I put this resistor switched, so I put that switch contact across that resistor, when the switch off, that resistor would be in series with this switch, with the pot, which would effectively be like turning the pot up. It'd be increasing the range. Be making it like a 100k pot instead of a 50, and putting it in the middle of the range, which is very similar to what they're already doing. And when you obviously turn it on, you'll be bypassing that resistor, be shorting it out, and it will give you the full pot range again. I reckon that's the way to do it. If I put that resistor on that switch, I mean the thing is that this side of the switch is going to the centre of the pot there. I think I have to cut that track, get rid of this resistor here, take that one away completely, cut that track there, bridge that side of the switch to that track because it's so close to it, run a jumper from that side to this side, and that would probably do it. Yeah, I think I'll go with that. Let's modify this thing. Take this resistor off. That can go. Bye bye MILF resistor. Don't confuse that with the MILF resistor, that's a completely different thing. And cut the track there. And I've got to link that track then to the centre of that one as well. So that centre of the pot, you can't see it, the damn thing I'm doing. There you go. Alright, so yes, let's do this. I should discuss this on video as well. So what I'm going to do is I'm going to use this switch to short across this resistor here. What I'm going to do effectively is put this resistor in series with the pot. So when the pot's in its zero position, that's like 0 ohms one side, 50 ohms the other. Sorry, 50k the other. If I put this resistor, which is 47k, in series with the pot in its last position, which it would be when the switch is off, so the switch is open, that would be putting that resistor in series with the pot, which effectively put the pot in about halfway position. Right, so start having the squelch halfway up manually. That's what it'd be effectively doing. And as soon as you turn the pot to turn the switch off, that'll put it right at the bottom of the range, and then you got full range on the pot manually. So I think that's what I need to do is modify this. I've already taken a little MILF resistor off here. I've got to cut the track there, and then I've got to put the switch contacts there across that resistor there, and then link this centre, the wiper I suppose, of the pot to the original position, which is over here. Right, that kind of connected there. So I'll go a link from there to there and bridge that switch contact across that resistor, and that should probably work. Probably. I'm thinking that they'll cut around, don't I? So putting on that side of the pot will make it higher. Yep. Haven't got it backwards. Right, let's cut the track here. could have made a quick drawing, sure, but yeah. Is that broken now? Yes, that connection is no longer there. So let's bridge. I could bridge either way actually, couldn't I? So that one's really close to this side. I think I'll go that way. Right. Yes, I'm using a screwdriver to scrape this. A heathen. Then I'll link this one to this side. Which way should I do that? I might just link it to there. Yeah. This will want to clean up properly with the alcohol as well afterwards. Blobby, blobby, blobby. I'm going to put a wire in there too. Don't like to rely on bits of solder like that. Although it probably could do it, it's fine this time. I'm not going to do it that way. Get it? Any other colours? I'm just going to do fine wires. It's that one. There's more bits lying around? I do. That's convenient. Strange, this little wire's getting hot. That side. So that's the switch. Now bridging that resistor in a kind of weird crossover way. Now I've got to put one link from that center, the wiper, to this one here. To make sure I'm not going to be hitting on the chassis when I do that. I think I'm going to be alright. Always go around this way. I think I will actually. I'm not going to go to the solder pad, I'm going to go to the track halfway around because it'll be stronger. Shorter distance. This likely to flex and cause problems. Right, stick some alcohol on this and we'll check for links and shorts and all kinds of other mess which I've probably screwed up. Right. That looks okay, then I'll do something to make sure it doesn't move and no problem. Just record a little video on this. So I've now linked them together a little bit. Kind of cleaned up, still a bit dirty, but it's probably better than it was in factory actually. Put some links across. I was going to check to make sure there's no shorts anywhere, anything that shouldn't be going to where it shouldn't be going, and if it's all good then I can do something to protect these cables and these little loops, make sure there's nothing shorting, you know, a bit of tape or something, you know, like liquid electrical tape, put a bit of that on there to secure it all, and I can put it together and it will probably work, hopefully. There's a little bit of solder on this one. There we go. A close look at it. Yeah, I'm happy with this one yet. Yeah, it's looking better. Okay, let's test it. Fine. That's fine. There should be resistance. Or no resistance. There should be resistance now. Correct. This should link over to here. It does, and nowhere else. Once it's on. Looking good.
Just put everything down.
Right. Let's put some liquid tape on this because I'm going to be bodging it. Oh, should I use the other stuff? The other stuff will be quicker. This tape takes a while to go off. Haven't used this one yet. Is this the right one? Yes. I normally use a orange one, but this one fell out the drawer before, so I might as well use this one. If it's going to work. It's probably end up going messy and being awful. Yeah, way too much. Actually, it's not really too much. Just need to spread it around a bit. Okay, I'll do it. Right. Mind your eyes. Don't look at it. It's going to take a minute. I'm going to turn the soldering iron off now. Turn the desoldering gun off now. And we've still got to sort the knobs out. But at least it should work now. Bit of luck anyway. Try and tidy my desk up a bit, make some room again. It's awfully crowded. It's hard yet. Just a bit up. Basically is. Because it's quite thick, it'll need to penetrate right through it, so that's why I'm being a bit, I don't know, generous with it, I suppose. Right, I'll do. Put these away. Right. Let's put it back together. Then sort the knobs out. It's been a long stream, this one. It's still going. 3 o'clock, what's that? 7 hours, is it? What's it, something like that? Where's the other nut? Okay, where do I put the other nut? There it is. Plugs in. Put this back together. Trying to pinch any wires since I've been disturbing everything. Things may not want to go quite back where they should do. So which kind of chance I was going to work now? Was it going to be completely broken? Could go either way. I had this bit of tape over the side here. Refit that. There to secure these wires around this corner. Rear screws, casing, strap, inner screws, yep. Let's make sure I haven't missed anything. Inner screws. Test now. You're impatient, aren't you? So I want to get back into the casing so it's kind of assembled like it's supposed to be. Alright. I'll test it now. Okay. Still got 76 megahertz signal coming in. Alright. Right, I've started reassembling it. It's not back fully together yet. I've just got the thing back into the front casing. Let's try it out, see if these knobs actually work. Now, obviously they're recessed right now and got knobs on them, but let's make sure they're both positions where I can get to them. Turn the power on. There's power. We have volume. That's good. Now turn the squelch up. It's all the way up. Let's reduce signal level till it cuts out. Okay, it's 100 dBm. There we go, squelch is working. Let's try auto squelch. Auto squelch. That's still present. Let's drop it down some more. Minus 110. Nah. Yeah, auto squelch isn't squelching. It's too much for it. Yeah. So auto squelch isn't actually doing enough. That's a shame. Anyway, you got no more squelch. That'll do. That's good enough for me. Alright, so unfortunately all our squelch isn't working quite right, but oh well. It's otherwise working. We'll shove that back in here. That's it. Does it sit a certain way or not? Tucked under. Like that. Okay. We had this other piece of tape and over there to hold these wires down so they don't get pinched when the thing goes together. Like that. Okay, good enough. Guess I missed that one. Seems alright. Okay. Put some rear case screws in, hold it back down. All our squelch is over. Well, it's not even all our squelch, is it? It's just a manual squelch level on a switch. It wasn't even really an auto squelch. And I've had like some radios, like CB radios I've had, which have I think the HR 2510, is actually more like an auto squelch. It does actually adjust levels manually, but yeah, this isn't. It's just a fake auto squelch. It's not really an auto squelch. It's just a preset squelch level. Anyway, so is that right down there? I think it is. Yep. So this is pretty filthy up here. Let's give us a clean before I do anything with this. We'll try and put knobs on here and not completely obscure it. Looks like it's been sitting around for a while. Yeah, let's get some cleaner stuff. Oh dear. Right, almost there. Just got to sort these knobs out and we can call it a day, I think. Try to get the worst of the gunk out here. It looks a bit more reasonable. Right. Knobs. I was going to have to use those ones, wasn't I? Yeah. Pushing right down is definitely too much. So the there's definitely too much of a standoff there. I need to cut a little bit off these. About that much. Or so. About that much there, I'd say. Both have the same problem, I reckon. Yep. Now I see. Does that mark about right? Maybe. Might be too much. Right, let's cut this off slightly. Maybe not quite as deep down as I said I was going to do. Slightly less than that one. Right, I think I might need to get some bigger cutters and I'll cut this through. Try not to squash it because I might crack. Since I don't have any options, I don't actually want to crack it. So I'm just trying to run it through so it cuts through like a knife, really. Right. Wish I had a little saw here. I don't have a little saw. That would that's really what I need. Let's look at the yellow one yet. This is not going through very quickly. I need to get a saw. I need to go and get a saw. I need to go outside to the garage and saw these down. I shall be back in a few minutes. Right, sewing has been completed. My wife made me a coffee because she's been out this morning and she just got back a little while ago. She's made me a nice good coffee, which I could definitely use. It's better. Right, shortened, even about the same length. It's really cleaning too. Everything needs cleaning. Alright, so let's chop it on there. Now I've still got that skirt on the outside, which I'm debating if I do anything with that now actually. It may or may not be alright. Like this, to just making it look messier. No, they are just touching. They are just touching. I'm going to have to do something with the skirt around the outside. Oh, that's annoying. This is likely to end up being messy. It's going to end up leaving a hole. I'll take too much of that skirt off. I'm still not happy with this. That almost works. Do you know, if I can find another one the same as this, I might just go with that. Let's see if I can find another one like that, just in case I do have another one. And yeah, actually you could spin it and then try and scrape the outside off with a file or something like that. I don't know, if I can find one which fits nicely. Oh, look at that, it's almost a perfect fit, that one. Is that the same as the other one? Slightly smaller. I mean, this one here would almost do it, eh? Two like that. Yes, I do actually have two like this. Oh, maybe I should see those. Maybe use those ones. I reckon I should just use those. They actually kind of suit it too. I think so. I think that might be the way to go. Oh, I just found another one. I did have one. Yes, look, there you go. I do have a pair of those. There's still an option. Let's look at this one first, eh? Oh, look, that's fine. That's fine. Push those ones down. There we go, look at that. That'll do absolutely fine. I'm happy with that. Okay. Video record time. So, I decided not to use those other knobs. I found some other ones that actually fit in these holes quite well. They're not perfect. They do go below the surface more than I'd like, but they are actually going to do the job really nicely. So I think I'm going to use these ones. I'll give them these ones here to use instead. That's much nicer. But it works. Wow, this has been a mission fixing this thing. Right, get these other ones. I've got this knob drawer that it's only barely fits in my storage. I have trouble getting anything in and out there. So I've got to put this strap back on as well. Just make sure it's not twisted, because that would be annoying for everyone. Right. Brilliant. Battery pack. Right way up. Antenna. Let's see. It's the manual scorch. The manual scorch is really high, actually. So I can tune anything on this. I don't know if I can or not. If there's anything around here. It's pretty dead in this area. Come on, scan. Yeah. Yeah, it's working. Right. So, antenna's on it. Radio. Pick up the radio. It's working. Can't do it for too long, otherwise I get a copyright strike or something. Anyway. It works. Brilliant. That was a mission. Anyway, at least I got it fixed. Okay, brilliant. Done. I need to take a photo of this or something. I don't know. And it's remembers the last setting as well. Let's put these away. I need to take a photo of this for the video and do an outro. First I need to type it a little bit because it's just awful here. Dear. Tricky bit is putting these things back in. They barely fit. Right. Almost got them in. Almost. Yeah, it's the one drawing. Second drawer does not want to go in, of course. I will have to sort that out later. We've been messing over that for 5 minutes otherwise. Okay. That. Turn the scope back off because I left that turned on. It does actually have a light on it as well, just there, which doesn't do that much. Barely see it. Obviously, it only shows up at night. So it wasn't quite what I was planning on doing today, but it was worthwhile. Trying to get a better shot. Come on. You get the light on the LCD so you can see it. Okay, that'll do. Picture of that. Come on, take a picture, you bloody thing. Not my hand in the way. Twice a meteor shower, is there? Right. Should do an outro now. Well, that's fixed, it seems. Seems to be working alright. You know, the knobs are not ideal, but they'll work. Do the job. Got a couple of, I don't know, bits here. Maybe I'll research these and find out more about them. Maybe I should get something a bit like this to have some in stock, or at least something with a longer shaft. So next time I get something like this, I'll actually have parts which I can use without having to bodge something in, make it work. I like to have a assortment of things to make things possible. But anyway, I was quite happy that I was able to get that sorted out. So I'll check out the other videos down below, other repairs and things like that. So if you're not already subscribed, if you haven't been here before especially. And Patreon support link over there. Want to support me on Patreon, help me to buy things to the channel, like, I don't know, maybe a assortment of pots which I can use. Okay. Right, cool, that's that done. Never do that job again. Yeah, exactly. It's the thing, if I get the parts, I'm never going to need them. Right. Shut this stuff down. Change views back to over here somewhere. Yeah, let's go that one. Turn the gear off. And I did just shut my scope down. I thought I pushed the button long enough. Turns out I didn't. Alright. Whew, that's a long stream. 7 hours. Brilliant. Hey, it's good though. Got stuff done. And thanks everyone for sticking by me for the whole time, if you've been here the whole time or even just turned up or whatever. Yeah, I think it's time to go and have some lunch, because it is now 3:15. Sit down, enjoy my coffee, have some lunch, go and do some other stuff. So thanks everyone for dropping by. It's good to catch up with you all and people participate in the chat. It's always nice to have people chatting away. Oh, and a slice of pizza. Yeah, pizza for lunch, that's an idea. Might be a piece of toast with nothing on it, just plain toast, just like bread, just burnt bread. Alright, catch you later. Thanks for dropping by, and I'll catch you whenever I do another stream. It might be next week, I don't know. I'll have to see how things go. Depends how I feel next week. Catch you later.